Today you're going to learn how to build a complete REST API with ASP.NET Core and C#, step by step. We will start from scratch, creating endpoints, connecting to a database with Entity Framework Core, and adding validations. You will learn dependency injection, async programming, and how to keep a clean code structure. By the end, you will connect your API to a modern React frontend and see it all working together. Let's dive in. Your company is building a video game store. The frontend team already built the game catalog UI. Your job is to build the backend that powers it. All the game data will live in a database, and you will expose that data via a REST API with endpoints to create, read, update, and delete games. This course teaches you how to build this backend end-to-end with ASP.NET Core and C#. You will start by learning how to create, run, and debug your first ASP.NET Core application from scratch. Then we'll go over the core concepts behind REST APIs and how to quickly implement the traditional CRUD endpoints in an ASP.NET Core API. As you implement your REST API, you will also explore the use of data transfer objects, or DTOs, to define the contract between your API and the frontend. Then you will see how to use extension methods and route groups to properly organize your API endpoints. You will also spend some time trying out invalid inputs to learn how to ensure they are properly handled by your API. Next, you will introduce real database support via the popular Entity Framework Core ORM framework, which is included with the .NET platform. This will be also a good time to explore the ASP.NET Core configuration system, which will help you avoid hard-coding important configuration details in your C# code. Next, you will explore in detail the dependency injection design pattern and how service lifetimes work in ASP.NET Core applications. You will also learn here how to properly map your entities to DTOs to ensure you maintain the data contract with your frontend while keeping a flexible data model. You will complete your REST API implementation by introducing the asynchronous programming model, which will ensure your application use the web server resources in the most efficient way. And to close, I'll show you how your REST API can nicely integrate with the frontend to light up a modern user experience. To follow along, you will need two things installed: the .NET SDK, which is what lets you build and run .NET applications, and Visual Studio Code, the editor we will use across the course. We will also add a few VS Code extensions, which I'll show you as we go through the course. With the SDK and VS Code installed, let's see how to configure your development environment. Let's see how to configure Visual Studio Code for .NET development. The first thing that we should do is to confirm that .NET has been installed properly into the machine. And for that, we can use the .NET Command Line Interface, or CLI. For this, let's go into the VS Code terminal that we can find by going into our menu bar right here. Let's go into terminal and then new terminal. And a quick tip here is that you can use the Ctrl+ shortcut, so Ctrl+ to open and close a terminal very quickly. Or on Windows, you can also use Ctrl+J. That's going to have the same effect. Now I'm going to click over here to expand that terminal for a moment so that it fills the screen. And now what we can do is just type .NET, which is going to give us access to the .NET CLI. And then let's just do --version, enter. And that, as you can see, is going to show us the version of the installed .NET SDK. One more thing that you can do here, if I clean this quickly, is type .NET --info, which is going to give us plenty of more information about the installed version of the .NET SDK. As you can see here, these are all the details about the .NET SDK. Also give us some details about Windows, as you can see over there. And there are many other details that you can find here about what you have installed related to .NET. And since we were able to pull up all of this information without any issues, it means that our .NET installation is correct. Now let's click on this trash can icon over here to kill this terminal. And let's move on to the next thing, which is going to be the installation of an extension that is going to significantly improve our C# development experience in VS Code. For this, let's go into the extensions view on the left side. Go over there. And here what we want to do is to look for an extension called C# Dev Kit. Should be your first hit over here. This is a C# Dev Kit. And this is going to be the main extension that is designed to help you build C# or .NET applications in VS Code. Let's click on the install button over here. Let's click on install. And after it completes, which should be pretty fast, yeah, it is done. What I want to show you is that this extension doesn't install just one extension, but actually a few. So let's click on this button over here to clear our box over there. Let me collapse it for a moment and this. And what you can see if I collapse this is that now we have a few installed extensions, which include the C# extension over here, which is the one that provides the base language support for C#, right? So that you can have proper syntax recognition of your C# code and all the IntelliSense support. Then, of course, you also get the actual C# the key extension that we installed, which is the one that is going to add a few nice additions to VS Code, like the Solution Explorer, so you can manage your projects and dependencies, and you can even run unit tests with that extension if you need to. And also at the top, we're going to see that we have the .NET install tool over there, which is actually an extension that is used by other extensions like the C# extension and the C# kit to install a version of the .NET SDK or runtime if those extensions need it. We will use a few other extensions across this course, but for now, this is good to start. Now let's collapse this. And now we're ready to create our first .NET project. How to do this? Well, there are actually a couple of ways to do it. The first way is by using the .NET CLI once again. So for this, let me open my terminal again. I'll do Ctrl-J, here's my terminal. And what you can do is type .NET new list, hit enter. And what this does is present you a full list of all of the templates for different types of applications that are installed with your .NET SDK. Now, if you go all the way up to the start, we're going to actually notice that the .NET SDK is presenting a little bit of first-time information about what you installed, telemetry, and a few other details I'm not going to be covering right now, but that only shows the first time. But the actual list is over here, right? So this is the list of your templates that you can use to create different types of applications. So for instance, if you wanted to create a brand new and empty ASP.NET Core application, you could use the web template that is over here. So from here, what you could do is, let me clean this. You could do .NET new web. You can give it a name, for instance, imstore.api, and that will go ahead and create your web application. But this is just one way to do it. And since we installed the C# Dev Kit, we have a better way to do this. So let me once again kill this terminal. And this time, let's go into our VS Code command palette, which we can access by going once again into your menu bar. Let's go into View, Command Palette. And again, a quick tip is to use the following shortcut to get there quickly. So in Windows, you can do Ctrl-Shift-P, and that's going to open up this palette very quickly. The palette is super useful, so it is really good to have a good way to get to it quickly. Now here, what you can do is just type .NET, and this is going to show all of the commands that are currently associated with the .NET SDK, as you can see. And the very first command is the .NET new project command, which is the one that we're going to be using to create our project. So let's just click on that one. And once again, this is going to give you the full list of all of the installed .NET templates that you could use to create your applications in Visual Studio Code. Now, for the purposes of this course, one of the templates that you could use to create your project would be the ASP.NET Core Web API template, the one that is right here. And this one would be ideal if you already have some experience with Web API development in .NET. However, I don't recommend this one if you are brand new to this kind of applications, because that is going to include a bunch of files and configurations that may be confusing from the start. Instead of that, I recommend that you start with the ASP.NET Core empty template over here, which is going to give you a clean slate with the minimal files and configurations needed to get started. And from there, you can start adding code and adding files while understanding exactly what each piece is for as you incorporate them. Let's go ahead and click on ASP.NET Core Empty. Let me switch into my projects folder. And here we want to create the folder that is going to become the workspace for our work in Visual Studio Code. And since we're going to be working on a game store application, I'm just going to create a brand new folder that I'm going to name Game Store. Okay, I'll go into that folder. I'll click on Select Folder. Then I'll enter the name for our application. Let's call it GameStore.api, since it's going to be a .NET REST API. Let's hit Enter. And here we're asked for the format of our solution file. The solution in .NET is what is going to tell VS Code what .NET projects you're going to be working with and how they are related to each other. .sln is really the old version and not very convenient, while .slnx is the newer, more modern version. So I recommend that you pick slnx whenever possible. So let's pick that one. And finally, let's go ahead and click on Create Project so that the project can be created. Now let me close my terminal here by going into these three dots. I'll go into Terminal and then I'll just click on the trash can. And as you can see, we have our new GameStore.api folder over there, which is the one that contains our .NET project, which is over here with a bunch of other files that compose our .NET application so far. And before we go through the files that got generated, one thing to keep in mind is that there are two ways to explore these project files. The first way is by using your File Explorer, which is the one that opens by default. So this is your File Explorer. And this is going to be a physical view that exposes every single file inside your project, including, as you can see, your solution file and even your bin and OBJ directories that I'm going to be talking about in a moment. But there's also another view that is known as the Solution Explorer, which is the one that you can see down here. If you expand this and perhaps we collapse this for a moment, this one here is the Solution Explorer. This is contributed by the C# Dev Kit. And this is going to be more of a virtual view of your application, which is only going to show the files that are mostly relevant for your C# development, and also gives you the ability to very easily start creating different types of C# files. Like for instance, you can right click here and you can start creating different types of files, as you can see over there. And you can also establish relationships between different projects, install NuGet packages, and a few other things. So we will be using both of these Explorer views across this course, but most of the time, I'm going to be preferring the File Explorer over here just because it is a very transparent view of everything that's going on in that project. Now let's go through the different files that got generated, and let's start by looking at program.cs, which is going to be the only C# file that we have so far. Let me collapse this. And the purpose of this file is to define the code that is needed to bootstrap your application. In particular, the main thing that we're trying to achieve here is to create an instance of this app object over here, which is really going to be a web application object, as you can see. We want to create an instance of the web application, and then at the end over here, as you can see, we want to go ahead and run it. But what is this web application object over here, where the web application is what we know as the host? This is the host of your application. And the purpose of it is to introduce an HTTP server implementation for your app so that you can start listening for HTTP requests. Now, as you can see, we don't just create the web application object directly. Instead, we use the builder pattern via this create builder object over here. And that is because we can use this builder object to configure a series of services for the application. Like you can always do builder dot, and you're going to see that there are many properties and methods that can be used here to define services, configurations, and a bunch of things for the application, as we're going to see across this course. From there, we invoke the build method that is going to also come in with a bunch of defaults for our application, like the use of the Kestrel web server, reading the settings from our app.json file or environment variables, and even how to configure login services. All of that's going to be done by this build call over here that is going to produce the web application object. So this section right now between lines 1 and 3 is a section where we configure all of these services for the application. And then when we have the application, we move on into this second section where we configure what is known as the HTTP request pipeline, which is where we define what is going to happen when these HTTP requests start arriving into the application. For instance, over here by default, as you can see, we're defining that when a request comes in via the get verb into the application, into the root of the application, we're just going to go ahead and reply with a simple hello world string that is going to go back into the caller. And the last line over here is going to go ahead and kick off the execution of the application in the Kestrel web server. We'll see much more about Program CS as we go across this course. For now, let's close this. Let's go back into our file explorer. And let's take a quick look at our GameStore.api.csprog file. This is known as the project file. It is common to all .NET applications. But in this case, it contains this SDK entry that uses Microsoft.NET.SDK.web. This is what defines what type of application we are working with here. In this case, a web application. And this is going to import all of the libraries that have been specifically designed for .NET web applications. Another important thing that is defined here is the target framework, as you can see over here. The target framework is what defines the set of APIs that are going to be available for your application. So if you have a lower version, you have less APIs available. But if you have a higher version, you have more and newer APIs available to you. In this case, I'm using .NET 10, as you can see over there, because that is the version that I used by default when I created the project. Now let's close this and let's go into our app-settings.json file over here. Now this file and also app-settings.development.json are the files that you can use to define all sorts of configuration that you don't want to be hard coding in your C# code. App-settings.json is the file that is going to be used by default in any environment, but you also have app-settings.development.json, which is the one that you can use specifically for local development. Now let's go into the properties folder over here, which is where we're going to find this other file called launch-settings.json. And this is a file that is designed to define what is known as profiles. And the profile is a place where you can define a few settings related to how you're going to be running your application during local development. Everything that's defined over here is only for local development and has nothing to do with how you're going to run your application in production. For instance, here we are defining that when we want to run the application using HTTP, the application URL is going to be the one that you can see over here, HTTP localhost 5159. The port, by the way, is defined randomly when you create the project. So very likely you're going to get a very different port when you create your own application. You can also see that you can define environment variables over here, like this ASP.NET Core environment variable over there, which is a well-known variable used to define that we are working on a development environment as opposed to a production environment. If you wanted to use HTTPS instead for local development, you can use your HTTPS profile, which is going to bring in one more URL. As you can see over here, we have HTTPS localhost 7083 in my case, which will allow you to run your application locally with HTTPS. Okay, now let's close this. And a few other things to notice here is the presence of these bin and obj directories, where here obj is going to contain the intermediate files that are produced by .NET before creating the final version of your DLL. And that final version is actually going to land over here in this bin directory. Lastly, as you can see down here, we have our .slnx file, which is the one that understands which are the projects that you're working with here in VS Code and how they are related. And in fact, it is this file, the one that powers the experience that you can see down here in the Solution Explorer. We will learn much more about all of these files as we go across this course. Now that we understand the structure of our .NET project, let's see how to build and run the application. And let's start with building the application. How do we build this? Well, there are a few ways. I think the easiest way is by using the Solution Explorer. So you can go into Solution Explorer over there. Let me collapse this for a moment. And from here, all you have to do is just right click on your project. So GameStore API, right click there, and then you can click on the build option. As you can see on the right side, a terminal opens and our application has been built and it has produced the output DLL right there. You can confirm the presence of that DLL by going into your file explorer. You can go into bin and you're going to find your DLL and a bunch of other files right there. Another way to do this is by using directly your terminal, right? So let me actually switch from here into a brand new, let me actually click on the plus sign over there to spin up a brand new terminal. I'll kill the other one to have more space. And from here, you can switch into your GameStore.api directory. And you can use the .NET CLI with the build command. Hit enter, and that will go ahead and quickly build your application directly from the terminal. So you can do this within or outside of Visual Studio Code. Lastly, you can also use the integration of .NET with the build task in VS Code. So you can do Ctrl-Shift-B, and that is going to open up your build task in VS Code. You can click on .NET Build, and again, that is going to kick off the building of your application as you saw. Now, how to run the application? Just like with building the app, there are also many ways to run the application in VS Code. But I think the easiest way is by just hitting your F5 key. So let's hit F5. And the very first time that you do this, VS Code is going to ask you a couple of questions. First, VS Code wants to know what type of application is that you're trying to run so that it can use the correct tooling for the execution. In our case, this is going to be a C# application, so let's pick C# here. Next, VS Code is asking for our launch configuration. There are several options here, but the main ones to pay attention to are going to be the ones related to our launch profiles, the ones that we saw in our launch series.json file. So here we have the option to start with our HTTP profile, and after that we can see the one to start with our HTTPS profile. For the purposes of this course, to keep things simple and to avoid any kind of certificate-related issues, we're going to pick the HTTP option, which also corresponds to the default configuration. So let's click on HTTP. And at this point, Visual Studio Code is going to first build the project once again, and then it's going to start the project execution. Notice that VS Code not only started our web server, but it also opened a browser to go into the root of the application. And as you can see, we have the hello world right here. And the reason why we see hello world is, once again, if we look at our program.cs file, let's go back into our program.cs file. Let me collapse this for a moment. We're going to remember that whenever a GET request is sent into the root of the application is expected to return hello world in plain text, as we can see over there. Now, one thing to notice here is that we are not just running the application, but we are in debug mode, which means that we can add breakpoints to inspect the state of the application as we are running it. And to show you this, let me actually stop the application for a moment so we can click on this stop button over there to stop debugging. So that stops the app. And this time, let's place a breakpoint right here in line 5. And let's start debugging the application once again. Now here, instead of hitting F5, let me show you another way to start debugging. You can go into your Solution Explorer. Let's collapse this. You can right-click on your GameStore.api, and you can click on Debug, Start New Instance. It's the same effect as hitting F5, it's just a different way to do it. Notice that this time, if we collapse this a bit and this a bit, we are breaking into the live execution of the application so that we can inspect the different objects that are alive at this point. So if we hover over app, we are going to see a bunch of the properties related to the app object over there. Over here, we can also see on the left side the different variables that are local at this point, right? Including our builder and all of its properties and the app. We could use watches. We could show also the call stack if needed. So you have full debugging support in VS Code. Now to continue the execution, I'm going to click on the play button over here. Let's click there. And this time, the browser opens once again, as you can see, and it's actually stopped once again because if we go back to VS Code, what's happening is that this time we are not in the startup sequence, but we are inside the handler for the get verb. So the browser made a get request into the root of the app, And this time, we are debugging that step, the step that is going to return hello world back into the browser. We're going to learn more about how this map get works later in the course, but for now, let's just click once again on the continue button. And back in the browser, we can see once again our hello world over there. Now, even when it can be very useful to start your application with a debugger attached, there is a faster way to start your app for your normal dev loop. So if you go back into VS Code, let's once again stop the application. Let's click on stop, close this. And what you can do is to just run the application without any debugger. And what you can do is go into your Explorer, in this case, your Solution Explorer, right-click on GameStore.api, and then you can go into Debug and into Start Without Debugging. So click on there. That is once again going to start application, but this time there is no debugger attached. And as you saw, it is much faster because there is no need to inspect the live execution of the application. That is one way to do it. Another way to do it, if we stop this again, is by doing Control F5. You can do Control F5. It's going to have the same effect. Very easy to get there, as you can see. And the last way is by using directly the .NET CLI. Now, before showing you that, let's stop this. One thing that I want to show you is that there is a way to prevent VS Code from opening the browser every single time. As you can see, we have multiple tabs open here, which not only is not ideal, but also we are going to be working on a server-side REST API that can be tested in a simpler way directly in VS Code without involving the browser at all. And I'm going to show you more about that later in the course, but for now, what we can do is go into VS Code and let's switch this time into our File Explorer. Let's go into Properties and into launch-settings.json. And here, if we go back into our HTTP profile, this is our HTTP profile, we're going to find this property here that says launch browser, says true. And what we can do is just flip this from true into false so that VS Code no longer launches the browser and just keeps us within the VS Code environment. So this time, if I do Control F5, I'll do Control F5 here. You can see the application starts, but we remain within the context of Visual Studio Code. There's no need to open the browser anymore. Okay, now I'll stop the application. And like I said, you can also run the application by using your .NET CLI. So for that, let me open the dots here. Let me go into my terminal. I'm going to kill this terminal for a moment. I'm going to clear the screen, expand this a bit. And while being in the GameStore.api directory, which is where our project lives, what you can do is just say .NET run, hit enter. And again, this is going to build the application and then start it. And as you can see, the console output reports the location of our API right there, localhost 5159. We can see that the application started. We can see our hosting environment, which is just development for now, and our content root path over here. I prefer this way to start my .NET application because I can always tell what's going on by just looking at the console output right here. But feel free to use any of the other options if that works best for you. So now that we know how to build and run our application, let's switch to slides briefly so that we can learn more about REST APIs. To understand what a REST API is, start by thinking about all of the apps you have in your phone, like your weather app, LinkedIn, or Spotify. These apps use a ton of data, but that data can't live in your phone, which is what we know as a client, because it would be way too much to store in your device and you want fresh data all the time anyways. So the data has to come from somewhere, and that somewhere is going to be some sort of server computer that usually lives somewhere in the internet cloud. But how can these apps talk to that server in the cloud to retrieve the data? Well, by using an API. API stands for Application Programming Interface, and it's how a service defines the functions it provides to clients. So for instance, going back to the Spotify example, the Spotify Cloud Service could define an API with two functions. A Get Recent Songs function that receives the username as a parameter and that returns the 10 most researched songs for the specified user. And there could be also a play song function that receives the song name as a parameter and that returns the stream for that song so that a client can play it. Like this, there could be dozens or hundreds of other functions offered by the service that clients can use to interact with it. So an API helps clients communicate what they want to the service so it can understand and fulfill the request. REST stands for Representational State Transfer, and it defines a set of guiding principles that impose conditions on how an API should work. We won't dive into each of these principles in this course, but the important thing to know is that thanks to them, you can build APIs that are scalable, flexible, and independent of the technology being used on the client and the server. So going back to the original question, a REST or RESTful API is one that conforms to the REST architectural style. Now, the main reason why we want to stand up a REST API is so that our clients can interact with the data that it manages. But how do they actually reach that data? Well, for this, it is good to first understand the concept of a resource in a REST API. In the REST API, a resource is any object, document, or thing that the API can receive from or send to clients. For instance, in our game store application, the main resource is going to be our games. That's what the clients want to query and modify. But in other applications, like the Spotify example, one of the resources could be the songs. And in the LinkedIn example, one resource could be the users and another one the LinkedIn posts. These resources will be hosted on some domain, which could be a public domain, an intranet location, or it could be just your dev box. And they can be accessed either via the HTTP protocol or the HTTPS protocol, which is a must in public environments. So when you combine all of this, you get what we know as a Uniform Resource Identifier, or URI. And that is what your clients will use to identify and reach the resources of a REST API. There could be more parts to this URI, but these are the essential elements. Now, how do you actually interact with a REST API? Well, just like with traditional web pages, when clients want to request something from the servers, they will send an HTTP request using the resource URI to the server, and then the server will send back a response. However, in REST APIs, these requests and responses will look a bit different depending on the specific HTTP method used to call it. The most common methods are POST, which creates new resources, GET, which retrieves the representation or state of the resource, PUT, which updates an existing resource, and DELETE, which deletes the resource. So these methods allow you to create, read, update, and delete resources. And therefore, they are also commonly known as CRUD operations. There are other methods too, but for the purposes of this course, we'll focus on these 4 ones. Let's take a quick look at each of these methods in the context of our game store example to understand better how they work. To request all games, a client will send a GET request to the game's endpoint, and the server will respond with something like this. The first part of this response is the status, which is 200 OK in this case. This means that the operation was a success. There are many other HTTP status codes that a REST API will send back depending on the result of the operation, many of them for failure scenarios. The next part is the body, which contains the list of games in this case. Notice that this body is not HTML, but instead the format of the response is known as JSON, which stands for JavaScript Object Notation. This is the de facto format for sending and receiving data in REST APIs because of how easy it is to read and write and is supported by all major programming languages. If instead of getting all games, you wanted to get a specific game, you would again send a GET request, but this time you would append the resource identifier at the end, number 1 in this case. The server will respond with the state of the game with that identifier, assuming it's able to find the game. To create a game, the client can send a POST request once again using the game's resource URI, but this time it needs to specify the desired resource state in the body of the request, which in this example only includes the name of the game, but could include many other properties. The server will usually reply with a 201 created status code, and if the resource identifier was not specified as part of the request body, the response will usually include it. To update an existing game, the client sends a put request with the same resource URI as the one to get a game, but this time it includes the resource state, just like in the post scenario. The server will completely replace the state of the game associated with the specified identifier with the new state, and will typically respond only with a 204 no content status code. Finally, to delete an existing game, the client sends a delete request to the URI that identifies the game to delete, and after deleting the resource, the server will usually respond with a 204 no content status code. So in summary, your complete game's REST API will look like this and should offer all the support that your clients expect from a modern backend. Let's now jump back into the code to see how to implement this REST API in ASP.NET Core. Before we start implementing our game store REST API, let me show you how to interact with your REST API in VS Code without having to involve a browser. And for that, we're going to install a new VS Code extension. So let's go into our extensions section on VS Code, extensions. And this time, let's look for REST client, which is going to be this extension over here. REST client by Wachao Mao is one of the most popular extensions to interact with REST APIs, although it's not the only one. There are many ones, but I like this one because how easy it is to use. So let's go ahead and click on install. And now let's go back into our file explorer. Let's close this. And what that extension allows us to do is to create a file where we can define all of the requests that we want to send to our API. So let's right click on gamestore.api. In our file explorer, let's click new file, and let's give the file the name of games.http. And here what we can do is to define the verb and the location of the API endpoint that we want to invoke. In our case, all we have, as we can remember, is in program CS, we have our get endpoint at the root that is going to respond with hello world, right? So going back into games.http, what we can do is just define a get call with the location of our local application, which is going to be http // and then what is the location? Well, to remember that location, you can always go into properties, launch settings.json, and remember that that location is going to be here for your HTTP profile in application URL. Here is your local host and port. So I'm going to copy this into games.http right there. And now we are ready to invoke our API directly from VS Code. Now, before doing that, let me open my terminal. Let me switch to GameStore API and let's do .NET Run. Okay, the application has started. Notice that it is running, in fact, in port 5159. So let's go now, collapse this a bit, and let's click over here where it says send request. Let's click there. And as you can see on the right side, and I'm going to collapse this now, we can see all of the details of the response that our application sent back into the client. And that includes our status code. We can see the 200 OK return right there. We can see the content type, which is simple text at this point. And we can see a few other things, but the main thing, of course, is going to be the actual response that our API is sending back. This is a much better way to interact with your APIs in VS Code that is not going to involve opening browsers all the time. Now let's close this, let's close that, and let's also do in our terminal Control-C to stop the server. I'm not really going to kill this terminal for now. And let's go back into our program.cs file to see how to implement our first API endpoint. Now I'm going to remove this breakpoint and I'm going to open here just one line to describe what kind of endpoint is the one that we're going to be implementing. So this is going to be a get endpoint that is going to be returning all of the games available in our API at any given time. And the actual location where those game resources are going to live is going to be under games. And the way to tell ASP.NET Core what to do when a GET request comes into our API is by using this map_get method that we already have defined here, but that so far is only responding to calls into the root of the application, which is this slash that we have here. So this first parameter that we have here is going to be the pattern that is going to be matched by this definition of a map_get method. In our case, of course, we want to modify this so that instead of just going for the root, the pattern should be /games. Now, the second parameter to this method is known as the handler. So this is the handler that tells ASP.NET Core what to do when a request arrives and is matched into this pattern that we defined on the left side. At this point, the handler only says that we want to return the hello world string back to the client. But of course, at this point, we want to actually return the list of games that are available on the API. However, before we can return that list of games, we first have to define some sort of representation of these games that are going to be returned back to the client. And for that, we need to define what is known as a data transfer object, or DTO. To create our DTO, let's go now into our Solution Explorer. So let's actually open up Solution Explorer. Let's collapse that. Let's right-click on GameStore.api and create a brand new folder that we're going to call DTOs. Then right-click on DTOs, click on New File, and here we have a few options to create a DTO. We could create a class for it, but I actually prefer to use a record type, this one over here, a record. And that is because records are ideal to represent simple data that is going to be carried over from one point to another without the need of modification. And they also reduce the amount of boilerplate code typically needed with having to use classes. So let's name this record game DTO. I'll hit enter. Let's open it in the editor and let's collapse this. Now let me hide my activity bar so that we get a little bit of more space like this. And now the question is what to place inside our new game DTO here. And so just to be clear, and I'm going to paste a little bit of a comment here. A DTO is really a contract between the client and the server, since it represents, well, a shared agreement about how this data is going to be transferred and used. So essentially, we want to put here all of the properties that we are agreeing to return back to the client when they request our list of games. Now, there are a few ways to represent your record types in C#. The first thing to notice here is that you can either define this as a record class, but you can also just say record. It is kind of a synonymous with record class, so we will keep it simpler like this. And also, we could define those properties here inside these curly braces, but a simpler way to do it is by just using a parenthesis here and define those properties directly there. So let me send this to the next line and close this over there. And let's define our first property, which is going to be the unique identifier of our game. Is going to be just an integer. So it's going to be int ID. The next one is going to be our game name. Then we will also have our game genre. The game price, which is going to be of decimal type, price. And lastly, we're also going to include our date only release date. And with this, we have defined our first DTO, and we are ready to use it as part of our new API endpoint. So let's close this and let's get back into program.cs. And before we can return those games back to the client via this new endpoint, we're going to need some sort of collection of games to actually return. So at this point, to keep things simple, we're going to represent this collection of games just as a simple list that we're going to be defining directly here in this file. And later in the course, we're going to see how to transition from that and into a real database. So here in my line 5, I'm going to define a brand new list of game DTO, which is our new type, for which I'll have to do control dot here, just control dot, to use my GameStore.api.dtos namespace. Let's define it as games. Okay. So here we're going to be defining our first game. Let me scroll down a little bit. Let's define it as a new game with ID 1. The name is going to be Street Fighter 2. The genre is going to be fighting. The price is going to be $19.99. And the date is going to be a new date only of year 1992, month 7, and day 15. Now let me send this to the next slide so we can see a little bit better, like this. And we do see that we have an issue with the price right there. And this is because the compiler is getting a little bit confused with this number. It doesn't know if we are trying to use a double or a decimal here. Now, since we defined this as a decimal, what we can do is to help the compiler by just adding a letter M here. And that clearly tells it that we want to use the number as a decimal. Now, it's probably best to work not with just one game, but multiple games. So I'm going to paste here a couple of more games. So let me just paste what I have from my clipboard over here. Paste. Okay, so now we have not just one, but 3 games. We have our second game. It's going to be Final Fantasy VII Rebirth RPG. Here's the price and the date. And lastly, we have our Astrobot game. The third game is going to be a platformer. Here's the price and the release date. Like I said, we're going to be using this list of games for the first part of this course. It's just an in-memory list of games. And later, we're going to transition into an actual database. Now, how do we use this list of games with our API endpoint? Well, let's scroll down a little bit. And really, all we have to do is to update our handler here, which is a lambda expression, to tell it that we no longer want to return hello world, but instead we want to return our list of games, like this. There are many ways to define your handler here, but what you can see here is one of the simplest ones. Now let's run the application and let's see what happens when we invoke our new games endpoint. So let me open my terminal here. I'm going to switch to Game Store API once again. I'll do .NET Run. Okay, it's running. Close the terminal for a moment, and then I'll go back into our File Explorer. I'll do Ctrl-Shift-E to open my Explorer very quickly. I'll switch briefly into File Explorer, not Solution Explorer. I'll open my games.http file, and I'm going to slightly modify the request that we have here so that it actually points into our games endpoint. Remember that our endpoint now lives under /games. So I'm going to copy that. I'll paste that over here just after the host and port, like this. And now we're ready to invoke our games endpoint. So let's click on Send Request over here. And on the right side, we are getting our 200 OK. This was a successful response. This time we are getting a content type of type application JSON, because now we are returning a collection of objects that by default ASP.NET Core is going to transform into a JSON response. And we can actually see that JSON response down here. Notice that this is an array where each element is going to be one of our games that we have in memory for now in our API. Here's game 1, game 2, and game 3. So our first endpoint is working as expected. Now let's see how to introduce a second endpoint, this time to retrieve just one game as opposed to the complete list of games. So for this, let's close this. Let's stop our server. I'm going to just do Ctrl-C here, close terminal, back to program CS. To declare our new endpoint, we're going to follow the same idea as our first one. So let's add a couple of lines. Let's add a little bit of documentation. This is optional. I just like to do it so that I know exactly what to expect from this endpoint. So this is going to target, again, the games path. But this time, we're going to also specify at the end of this route the actual ID of the game to retrieve. So if we want to retrieve game number 1, we're going to pass the number 1 over here. This is the correct way, the RESTful way, to retrieve a resource by its unique identifier. So to implement this, we're going to do app.mapget. We're going to start with the same path, so /games. But this time, we need to specify the ID. And for that, we're going to include another slash here. And we're going to open and close curly braces. And we're going to insert here what is going to be the name of the property that is going to represent that incoming ID. And to use it, what we're going to do is to add our second parameter, which is going to, as you know, is going to represent the handler for this method. Here, we're going to start once again with the parentheses, but this parentheses section is actually our opportunity to define that ID, that parameter that is going to be incoming. So in this case, we're going to receive an int ID that is going to match exactly the name of that parameter that we defined in the path, right? It is the ID. And then once again, we need to define what is going to be the logic that needs to be executed when a request comes in with this exact pattern that we have defined here. So in this case, we're going to start by invoking our games collection, but this time we need to find the correct game. So one easy way to do this will be to just invoke the find method. So we do find, and we're going to say that we want to retrieve the game where game.id equals the ID that we received as a parameter. And that's really all we have to do. Notice that ASP.NET Core is very smart, and it understands that if we are going to receive a parameter named ID here, it will expect that ID to come as part of the route over here. Now let's run our server once again so that we can try out our new endpoint. So I'll open my terminal, Ctrl J. I'll do .NET run. Okay, the application is running. Going to close this terminal. Back into games.http. The way that we define a new endpoint here or a new request is by separating them by the pound sign. We have to do 3 pounds. And now it's going to understand that what we have here is a brand new request. Now this request is going to be pretty much the same as the previous one. So I'm going to copy that for now. Paste it here. And the difference is that at the end, I'm going to request one specific game. So let's say game number 1. Let's click on send request. And sure enough, on the right side, we are once again getting a successful response, 200 OK. Application JSON. And this time down here, what we see is the response that corresponds to our game number 1. Great. So now we know how to retrieve the full list of games and also how to retrieve one specific game. But what if we wanted to introduce a brand new game into our collection, which corresponds to a post request? So let's see how to implement that. Let's close this and Ctrl J. I'm going to do Ctrl C to stop my server. Back into Program CS. Let's scroll down a little bit. And once again, we're going to define one new endpoint over here. Now, this is going to be a post endpoint that again is going to target our games route. But before implementing it, the one thing that we're going to need here is a brand new data transfer object or DTO that is going to represent the incoming payload for the game that we want to create in our REST API. So let's first create that DTO and then let's come back here to implement the endpoint. So I'll do Ctrl-Shift-E to open my Explorer. And I'm going to switch once again into our Solution Explorer. Let's right-click on DTOs, new file. It is going to be a record type. And let's name this one create game DTO. Let's click on the file, collapse this. And like I said, we don't have to use record class. It can be just a record. That's good enough. We're going to once again switch to the other syntax that uses parentheses. And inside these parentheses, we're going to define the properties that we expect to receive from our client. In this case, we're going to start with the name. We're not going to start with the ID because the ID is usually generated and provided by the server after the resource is created. You don't usually get the ID directly from the client. So we will just do the name. We will use the game genre, the decimal price, and then our date only, release date. And that's all we need for our new DTO. So let's close this and let's get back into Program CS where we're ready to implement our post endpoint. So this time we're going to do app.map_post. Notice that there are many variants of map that we can use here. Post is the right one to use for this case. Again, we are going to start with our games route. And then we're going to be defining what is going to be our new handler. Now, in this case, in the parentheses here, we're going to be receiving the instance of the create game DTO that we just implemented. So we're going to receive create game DTO, new game, let's call it. Let's open our Lambda expression here to define the body. Once again, notice how ASP.NET Core is going to be fairly smart here in such a way that it is going to detect that the body that we're going to be sending from our games.http file, which is our client, needs to be deserialized into this object over here that we're calling new name. And in this case, since our list of games is really stored in memory in this list that we know we have over here, all we want to do is just to create a brand new instance of game.dto and insert that game into this list. So for that, let's scroll down here. Let's define our game.dto. Game equals new. Let's close this. And here we're going to be defining the ID. That's the first property. So for the ID, all we're going to do is just say games.count plus 1. That's going to be the ID. For the name, we have new game dot name, new game dot genre, new game dot price, and new game dot release date. Okay, our new game is ready there. Now we're going to add it into our list. So games dot add game. And finally, we have to return something back to the client. And the convention here for a proper REST API is to return a 201 response, which means created, means that the game has been created. And usually you want to also return the payload of the created resource. Now that we can do in the following way. So we're going to say return results.created route. There are a few ways to do this. This is just one of them. And for the first parameter here, we're going to be providing what is going to be the name of the route that the client can use to reach the just created resource. Now, what is that route? Well, that route is going to be up here, right here. It is this one here, the map get, but we have not yet assigned a name to the route, which is really optional. But in this case, we do need it because we want the post endpoint to understand that route so that it can create the proper URL so that the client can navigate to it. For that, all we have to do is to just chain a call here under map get. We're going to chain a call to with name. And here we're going to assign a name to this route. In this case, let's just name it getGame. And now we have a way to refer to this route in other endpoints. So let me just copy this getGame, going back into the end of our map post. And I'm going to paste that over here. So that's the first parameter. The second parameter is going to be the unique identifier of the brand new created game that can be used as part of the getGame route. Remember that that other route is going to receive an ID, right? Remember, it receives an ID. So we need to provide that as a parameter into map post to complete the route. And for this, we can use a simple anonymous type. So we're going to do new ID equals game.id. And for the final parameter, we want to provide the payload or the body of the resource that just got created. So that's going to be our game. Now, a good practice here is to not hardcode the same string multiple times in the application. But right now we do have getGame defined over here in the post endpoint, and also we have defined it over here in the getById endpoint. So what we can do is to refactor this into a small constant that we can use in both places. So I'm going to click in the light bulb over here to look at our refactorings, and I'm going to pick the introduce constant refactoring. I'll select introduce local constant for getGame. And as you can see, the constant had been introduced over here in line 31. It named it endpoint name, and it is using it right now in with name over here. Now let's give it a better name. So I'm going to press F2 here to rename this constant into something more meaningful. Let's call it getGame endpoint name. Enter. And now we have a better name for the constant. I also like to have these constants at the very top of the file, so not really in the middle of the application. So I'm going to just cut this, remove this. I'll go all the way to the top, and I'll define it even before our builder object, just after our using declaration over there. So that's our constant. And now we can grab that same constant. I'm going to just copy it and use it down here for our post endpoint. There. So now we have our post endpoint ready, and we can try it out via our games.http file. So let's start our server once again. I'll open my terminal. I will do .NET-run. Okay, the server is running. Close this. And then back into games.http. What we want to do is to introduce a brand new request. So let's do £3. Let's define that this is going to be a post, right? So we have to start with post. The route is going to be pretty much the same. So I'm going to copy that route over here. But this time we have to do a couple of new things. First thing is that we need to specify what is the content type of this post. Now in this case, it is going to be content type application JSON. And then we need to define what is going to be the body to go along with the request. Notice that you need to leave one empty line over here for this to work. So line 9 is going to be empty. And in line 10 is where we're going to introduce that body. We have to use proper JSON syntax here for this to work. So we will start with curly braces. And then we're going to be providing all of the properties that we defined in our DTO. Remember that if we go back to Ctrl+Shift+E into our game store DTOs, create game DTO, we have defined that we need to provide a name, genre, price, and release date. So we have to provide all of those as part of that JSON payload. Close this. Let's define our name. In this case, it is going to be, let's say, Super Mario Bros. Wonder. Fantastic game. The genre is going to be platformer. Then we have our price. It's going to be $59.99. And then we have the release date, which is going to be 2023, 10/20. Okay, so that's all we have to do. So now let's click on send request to create this game in our API. So let's click on that. And on the right side, we can see that indeed we got the expected 201 created status. Okay, that means that the resource was created in the REST API. And down here, we can see the response that we got from that creation over here. Here's a response, which includes the brand new ID for the created resource. And not only that, we also have this time what is known as the location header over there. We get this because we used the created@route method that is smart enough to understand where is that the client can go to look for the just created resource. As it says there, we can go into that location to retrieve the brand new resource. So you can go ahead, copy this. So let's just copy that. And we can go back over here into our get by ID. We can just replace this entire thing with that other string, click on send request, and now we can retrieve the Super Mario Bros. Wonder game. Great. So we now have endpoints for getting resources and for creating resources. Now it is time to create an endpoint to update an existing resource. So let's close this. I'm going to stop my server once again. Close this, back into program.cs. Let's scroll down a little bit more. And here we're going to be defining our brand new endpoint, which is going to be a put endpoint that again is going to target our games route. But this also has to include the ID of the game to update. So if you wanted to update game number 1, we have to include the number 1 over there. And then provide the body of the put request. Now, just like we did with our post endpoint, we need to define here what is going to be the shape of the payload to send into our put endpoint. And for that, we are going to need a brand new DTO. So let's do Ctrl+Shift+E to go to our Explorer. Let's switch to Solution Explorer. Let's right click on DTOs, new file. Let's select record. And let's name this one Update Game DTO. Enter. Let's click on Update Game DTO and let's collapse this. Let's follow the convention of the other DTOs by not including class here. It's the same thing, public record update game DTO. Let's also switch into the parentheses syntax here. And now let's introduce the properties that we're going to be receiving in this endpoint. So again, this is going to be our name, our genre, our decimal price, and our date only release date. And now that we have our DTO ready, let's go back into program.cs and let's implement the new endpoint. So for this one, we're going to do app.map put. The pattern is going to be again, slash games, we need to receive the ID. So we're going to introduce ID here. And then we're going to define our Lambda expression. So let me prepare the body here. And let's start filling in what's needed. Now, in this case, we need to receive two parameters into our Lambda expression. The first one is going to be, of course, the ID, so which is the game to update. So we're going to do int ID. And the second parameter is, well, the payload of the game that we need to update. So for that one, we'll do update game DTO, updated game. Again, ASP.NET Core will be smart and will understand that the first parameter is going to come directly from the route, while the second parameter will come from the body of the request. Now, what is going to be the logic here for the update? Well, the first thing to do is to locate the game that we need to update. So for that, let's do the following. Let's do var index. It's going to be games.findIndex for the game where game.id equals the provided ID parameter. So that's going to give us the index. And now, based on that index, we can go ahead and update the element in our collection that corresponds to the index. So we're going to say games sub-index equals a new game DTO that is going to have as the first property, the ID is going to be just the provided ID. And then we're going to have the updated game.name, updated game.genre, updated game.price, and updated game.release date. Okay, so that's going to update all of the properties of our existing game. And finally, we're going to return, as a good convention in REST APIs, we're going to return results.noContent. And that's pretty much it. That's how you can implement this first version of our put endpoint. Now let's go ahead and test it. So I'll start my server once again. I'll just do .NET run in my terminal. Okay, I'll close this. Back into games.http. Let's define a brand new section here. Scroll down. I'll do my 3 pounds. This is going to be a put. Once again, to the same location. So we're going to do all of that. I'm going to paste that here. Like I said, we need to specify what is going to be the ID of the game to update. Now, to remember what IDs we have, we can, of course, go ahead and just retrieve the full list of games via our first request. So let's click on Send Request. Here are our 3 games. So let's say we're going to be updating our Street Fighter 2 game. Perhaps we're going to change the name slightly, and we're also going to change the price. So this is going to be game number 1. And to keep things simple, I'm going to copy this JSON. I'll copy that, close. So the ID is 1. I'm going to include the ID in the route. I'll leave a space. I'll paste what I just copied there. Let's align this better. There. And then the main difference here is that we're not going to need the ID because it comes as part of the route. So we can remove that. And then we need to specify what are going to be the changes to introduce. So this is going to be now Street Fighter 2 Turbo. This is one variant of the game. And for the price, we're going to see that it is on sale. So we're going to remove this one so that the price is going to be just $9.99. Don't forget to also define here what is going to be the content type. So content type is going to be application JSON, just like we did with post. So let's click on send request. And sure enough, we got our 204 no content, which means that this was a successful request. And we can, of course, confirm that the game was updated by just querying again the same game via our get by ID request. So I'll switch this to 1. I'll hit send request. And indeed, we can confirm that the game has been renamed. It is a Street Fighter 2 Turbo, and the price has changed. So the update was a success. Now, there's one thing to keep in mind with this update or put endpoint. So let me just close this and stop my server for a moment. Let's go back into program CS. And the thing is that there could be multiple put requests being sent into our API and trying to make this modification at the very same time, which here is possible because the games list here is a static list, right? And if we have those multiple threads trying to access and modify the data at the same time, that could of course lead into data inconsistencies. So for a production level application, using a list like this is not going to be a great option. You want to use something different, perhaps a concurrent back or something else that is actually thread safe. In our case, we are just at a transition point, learning how to create our REST API, and later in the course, we're going to switch into a proper database, and we're going to get rid of this list completely. So just something to be aware of if you plan to take this into production. Now let's see how to implement our last endpoint, our delete endpoint. And for that, let's scroll down here. Let's insert a new section before app.run. And this is going to be a delete call into games. And again, it is going to receive the ID of the game to delete. Let's say it is going to be game number 1. That is how we would invoke the endpoint. Now, fortunately, the delete endpoint does not need any DTOs because it only receives the ID of the game to delete. It is not going to return really any payload. So we can go ahead and define our endpoint right away. We're going to say app.mapDelete. We define the path here. Games, we have to provide the ID. And then we define our lambda expression receiving the int ID. Let's define our body. And since the purpose of this endpoint is to delete the game that corresponds to that ID, what we can do is just say games.removeAll, where the game is the one where game.id equals the provided ID. That is a simple way to remove the game. And then we're going to once again respond with return results.noContent, which is the convention for properly built REST APIs. Now, notice that it doesn't really matter if the game exists or not in the API. The convention for a delete endpoint is that after the endpoint receives and processes the request, the resource should no longer exist, regardless of if it existed before or not. Because of that, we are not even checking if the game exists. We're just going to remove any instance of the game where the ID is the one that was provided. Okay, so let's test this new endpoint by starting our server once again, .NET Run. Let's switch into our games.http. Let's introduce one more entry over here, triple pounds. Let's do delete. Let's copy and paste our path from the put endpoint. And let's say that we're going to actually delete our very first game. So game number 1. Let's first confirm what is going to be the complete list of games before doing the deletion. So let's click for our first request here, send request. Here it is. Remember, we have games 1, 2, and 3. Now let's go and execute our delete request. So let's send request. We got our 204 no content, meaning that this was a success. The game must not exist anymore. So if we go back into the first request, let's retrieve the full list of games. And as we can see, game number 1 is gone. It is no longer available here. And like I said, we could invoke the same endpoint once again with number 1. Even when it does not exist, we can hit send request. And again, we're going to get 204 no content because the client doesn't need to know if the game existed or not before. The convention is to just ensure that the resource does not exist after the endpoint was invoked. One thing you may be wondering is what happens if we try to retrieve a game that does not exist. So what happens if we try to use our getById endpoint, this endpoint over here, but we provide the ID of a game that is just not there? Well, let's try it out. Let's see what happens. Let's start our server once again. Let's go to games.http. And this time, let's try to retrieve, let's say, game number 5, which does not exist at all. Let's click on send request. And as you can see, the response is a little bit unexpected, right? So we are getting, once again, a 200 OK, which is already not a good thing because this was not a success. We were not able to find the game. And even worse, we are getting, or we're returning a null value over here. So this is not a good REST convention because the REST guidelines clearly indicate that if the resource is not there, you are expected to return a not found response. Let's fix this. Let's close this. Let's stop the server. Let's get back to program CS. And we're going to do the following. So going back into our getById request, let's start by giving it a proper body. So I'm going to open and close curly braces here. I'm going to bring this inside our curly braces like this. And then what I'd like to do is to actually capture the result of our games.find call so that we can check if we were actually able to find the game. So we're going to say var game equals games.find. Let's fix this briefly. And then what we can do is the following. Since our game variable here is going to be actually nullable, notice the question mark here, it means that it could be null. So we will say that we're going to return if game is null. So if it is null, we are going to return actually results.notFound, which is the expected response when the resource cannot be found. And otherwise, we are going to just return results.OK, including our game object there. And that should be good enough to return the correct response depending on if the game exists or not. So let's try this out. Let's go ahead and start our server once again. Let's go into games.http. And once again, let's try to retrieve game number 5. Let's see what happens. Let's send the request. And sure enough, now we are getting the 404 not found. There is no null returned here. And this clearly tells the client that the requested resource is just not there. Now, in a similar way, we should deal also with our put endpoint, right? Because that also is going to try to locate that resource. So let's scroll down here into my put. And here, just after finding the index of the game, we're going to say that if the index equals -1, which means that we were not able to locate the index of the requested game, we're going to just return results.notFound. Now, the fact that we are returning not found in this case when we're not able to find the resource is a little bit a polemic statement, because some people will say that what you want to do instead is just create the resource if we're not able to find it to satisfy the requirements of a pull request. Now, there is not a definitive answer to this. And for the purposes of this course, I'm just going to go for the not found approach that we have over here. So let's test this very briefly. Let's make sure it is working as expected. So we're going to start our server. Let's go into our put endpoint. Let's try to update again game number 5, which doesn't exist. Send request. And as expected, we are getting our not found response. Now, one thing that may concern you at this point is how much code we have in this program.cs file. Because if we keep going this way, it is going to get more and more challenging to locate things in the file and to make quick changes, right? So this is not really a good practice. So what we can do is to move all of these endpoints that we have declared in program.cs so far, just move them into a brand new class specifically designed to define the endpoints. And that is also going to provide us an easy method to map all of the endpoints at once. So for this, let's go back into our Solution Explorer. So Ctrl+Shift+E. Here we are in Solution Explorer. And let's start by defining a new folder for our endpoints. So let's right-click on GameStore.api. Let's create a new folder. Let's name it Endpoints. And in this folder, let's create also a brand new class. So let's right-click on Endpoints, new file. It's going to be a class. And let's name this one Games Endpoints. Enter. Let's go into gamesendpoints.cs now. Now I'm going to remove this unnecessary using. And like I said, the purpose of this class is going to be the one that contains all of our API endpoints. And we're going to do that by using what we know as extension methods. Now, extension methods always live in static classes. So we're going to turn this one into a static class. Now, before we define our extension method here, Let's start by moving in our collection of games. So let's select the complete set of games here, the full list. Let's right click, let's cut this, and let's take it into games endpoints.cs. Let's paste it right here inside our new class. Let's format this a little bit better, like that. Let's hover over game DTO. Let's do control dot so that we can import our GameStore.api.dto's namespace. And since we are now into a proper static class, we need to define this the right way. So this is going to be a private static list of game DTO that we're going to name games. Also, since we are not going to be assigning any new value into this games object after the construction of our games endpoint class, one good convention here is to define this object as a read-only object. So we're going to do read-only, and that completes the definition of our list. Now going back into program.cs, the next thing that we should move is also the definition of our constant here, our getGame endpoint name constant. Let's cut that and let's bring it into our games endpoint as a constant at the top. Now it is time to define our extension method. So let's scroll down. Just after our list, we will define our method the following way. So this is going to be a public static because all extension methods are static. We will return void. Let's name this one map games endpoints, since this one method is going to map all of the endpoints. And then we need to define what exactly is that we're going to extend, meaning that we're going to add new methods to whatever object we're going to be passing here. To extend an object, we're going to start by using this keyword, and then we're going to define what to extend. The thing that we want to extend here is actually going back to program.cs. We want to extend the app object here, which is really of type web application. So for that, going back here, we're going to define web application app. And then let's get ready to define the body of the method. For this, really all we have to do is just to bring in the definition of all of our endpoints. So let me just grab everything here all the way to the delete endpoint. I'm going to right click and cut back into games endpoint. Let's just paste what we just copied. And now we are doing the same thing that we did before, but now we're doing it in the context of this brand new extension method. So notice that it is pretty much the same code, nothing changes. We're still adding all of the methods into the web application object, but now inside this map_get_games_endpoints method. And with that, we can go back to program.cs. And here where we have now this empty space, we can now say app.map_games_endpoints. Fix the casing, and let's do it like this. Let's do control dot to import our new GameStore.api.endpoints namespace. Let's also clean up a little bit this space over there. And now this is the full contents of our program.cs class, which, as you can see, is going to be much more easier to maintain as opposed to having dozens and dozens of lines of code here. Now, going back into games endpoints over here, one more thing that we can do is to also simplify a little bit the way that we are defining our endpoints. Because as you can see, we are defining our games route multiple times, right? So we define it over here and over there in the get and really in every single endpoint. And that is prone to error. So instead of that, what we can do is to define what is known as a route group that is going to define the base part of the expression. And then we can attach each of the endpoints into that group. So for that, what we can do is open a new line over here. I'll just say var group equals app.mapGroup. Here we're going to introduce the actual path, which is going to be /games. Let me copy that. We put it over here. So that is our group. And now instead of invoking map_get and map_post and all these on the app object, we can now call them on the group object. So let me copy group and let's replace all of our app calls with group. So group map_get, group map_post, group map_put, and also group map_delete. Now, the next thing is, of course, that we no longer need to define gains for every single endpoint because it is inherited from the group. So we can now reduce this into just slash, which is still going to result in the endpoint to be defined under slash gains, but the endpoint itself doesn't have to define that. That is going to be taken from the route group. Same thing, we can go for map get by ID. We can remove this, leave it just like that. Map post can be this. Map put can be like this, and map delete can also be like that. A very important aspect of REST API development is the validation of the input to our API endpoints. And to see why this is important, let's see what happens if we modify our post request over here so that we don't provide any name for the game. Right, so I'm going to remove this completely. Now the game has no name. And even with this, I'm going to click on send request. Let's see what happens. Okay, so the resource got created. We have a 201 created over here. However, now we have a game with no name as part of our API resources. So this is inconsistent data, and this is something that potentially is going to cause lots of trouble down the road. Now let's see how to prevent this. Let's close this, and I'm going to stop my server for now. Let's go back into our endpoints and gains endpoints. And let's find that post endpoint over here to see what we can do about it. One thing that we could do is, for instance, if we are receiving this new game with the create game DTO, well, we can go ahead and validate the properties here before letting any of the further logic continue, right? So here in my line 49, we could do something like, well, if string that is null or empty, new game dot name, we could do something like return results request, and we could even provide some message here, right? So name is required. That would prevent the rest of the logic to continue if we don't have the name. But of course, just as we did this, we will have to go through each of the different properties of our DTO, right? The genre, the price, all of these other properties to make sure that we are validating every single thing. Now that would work, but it's going to get very verbose across this method. And if we do it for every single endpoint, it's going to result in lots and lots of lines of validation. So instead of doing this, and let me just remove these lines, what we can do is to modify our DTO itself so that the different properties declare what are the validation rules on them. So here I'm going to hit F12 to go to the definition of our create game DTO. Over here, here's create game DTO. And what we can do is to define what is known as data annotations on the different properties. So for instance, for our name, I can define that the name is required. And for this, I'm going to do control dot, and I'm going to select the system.componentModel.data annotations namespace. This attribute is going to make sure that even before the DTO object is accepted into our endpoint, ASP.NET Core is going to validate that the name actually has a value, and otherwise it is going to return a validation error automatically. Now, adding this attribute here into our DTO property is not enough for the input validation to happen. You also need to activate or register the validation services so that ASP.NET Core can use them. For that, let's go back into our Explorer, Ctrl-Shift-E. Let's go into program.cs. And here's where we can use our builder object to register additional services that we want to get activated as part of our application. So for that, let me add just a couple of lines here. And what we can do is the following. We're going to say builder.services, which is the collection of all of the services that we want to get registered with application. And we're going to do add validation. With this, the validation services are going to be available for every single endpoint in our API. So now if we run the application once again, so let's just do .NET Run. Okay, let's go back into games.http and let's try out once again this post request that has no name, right? So let's hit send request. And this time, as expected, we are now getting automatically a bad request right there. And we can see down here a very nice error response that clearly says that one or more validation errors occurred, and it clearly tells us what is the exact property where the validation error happened. In this case, it is the name property, and it says here that the name field is required. As you can see, very easy to implement, and it did not require us to modify at all the logic of the post endpoint. It just looked at the attribute that we added into the create game DTO. Now let me stop my server, and let's improve this a little bit more by validating that not just the name is required, but also we don't want to allow very long strings for our game names. So for instance, here we can say string length, and here we're going to provide the value of the maximum length for this string. So let's say that this is going to be just 50 characters. That's going to be the longest possible name for one of our games. So with this, if we execute the application once again, let's do .NET Run. Let's get back into games.http. I'm going to revert that change to take back our name of our game. But this time, let me actually, just to prove that this works, I'm going to copy and paste that name several times. So this should be longer than 50 characters. And now I'm going to go back to the start. I'm going to try to send a request. And as expected, once again, we are getting a bad request, but this time not because we are missing the name, but as you can see right here, the field name must be a string with a maximum length of 50. So that is how you can validate the length of your strings. Let's close this. Let's remove all of these extra strings. Let's stop the server. And now we have done that for our name property. Perhaps we want to do the same for our game genre, right? So let me go ahead and copy this. I'm going to paste it here. For our genre, we're going to require smaller strings. So let's say 20 characters. And then let's also go for our price. So the case of the price is that, well, what we want is to make sure that our price is a positive number. And perhaps we don't want to allow prices of more than, let's say, $100. So for that, what we can do is use the range attribute. So I'm going to say range from 1 to 100. So now if we run the application, once again, close this, back to games.http, this time let's try to introduce a game with a price of, let's say, $559. So let's send a request. And as we can see, once again, we get the bad request. And this time it says clearly here that the field price must be between 1 and 100. So that kind of price is not allowed. Okay, let's close this. Let's stop the server. And at this point, that's going to do it for our create game DTO. But we should do the same thing for our update game DTO, right? We want to also introduce these validations for the put requests. Now for this, what I'm going to do actually is just copy these properties for now to do this a bit quicker. So copy, let's do Ctrl+Shift+E, update game DTO, and let's paste what I just copied over here. Is the same set of properties in the end. Let's do Ctrl+ here to introduce system component model.data annotations. And now we should have the same set of validations on our put endpoint. So let's try that out very quickly. .NET Run. Let's go into our games.http. Let's go down this time into our put request. This is going to be for game number 1. And let's just try this time what happens if we have an empty genre, right? So empty genre. Let's click send request. And sure enough, once again, we got a bad request. And this time it is because the genre field is required. Feel free to validate the other properties of our put request, but I think you get the idea of how easy it is to enable input validation by using both data annotations and the validation services that come with ASP.NET Core. At this point, we want to add database support to our REST API so that all our data is persisted beyond the lifetime of the application. So whenever a request to create a game is received in our API, we want to create that game in the database. And when the client requests a list of games, we want to query that list also from the database. However, there is a problem. The database does not speak the same language as your ASP.NET Core API. Your API is coded in C#, but your relational database server only understands the SQL or SQL language. That means that to fulfill the request to retrieve games, your C# code needs to translate the API request into a carefully crafted SQL query, and then send that query to the database server. The database server executes the query, and then your C# code has to read back any resulting rows and translate them into a corresponding API response. This presents a few problems. As a C# developer, you now need to learn a completely new language, SQL, in order to craft the required queries. And you need to learn it well to ensure you get good performance out of it. You'll need to write a lot of additional data access code whose only purpose is to translate things from C# to SQL and vice versa. And of course, deal with unexpected errors. Talking about errors, this approach is error-prone, since it's very easy to make mistakes when mapping things from one side to the other. And you need to manually keep your C# models in sync with the corresponding database tables, which can be quite challenging. This is where Object Relational Mapping Techniques, or ORM, can make a big difference. But what is ORM? Well, going back to our Spotify example, imagine your application has been created using an object-oriented paradigm, and therefore it includes objects to represent songs, artists, and playlists. And if you're working with a relational database server, there's a good chance your database will have corresponding tables for each of those objects. Now, instead of having to write custom code to map these objects to tables each time you need to send or receive data to or from the database, you can set up a map between them so that your program can keep working with objects while another component, an object relational mapper, takes care of transforming objects to tables and vice versa. So in essence, object relational mapping is a technique for converting data between a relational database and an object-oriented program, and as you can imagine, it brings many benefits to application developers. And fortunately, ASP.NET Core includes a great ORM framework called Entity Framework Core. So what is Entity Framework Core? It is a lightweight, extensible, open source, and cross-platform object relational mapper for .NET. Entity Framework Core will sit between your REST API and your database server. Besides mapping your .NET objects to database tables, it will translate your C# data access code into SQL statements that the database server can understand. And it will also translate any resulting data from the database into objects that your API can easily manage. Using Entity Framework Core in your .NET applications brings in multiple benefits. There is no need for you to learn a new language. You can perform all data access tasks using your familiar C# language. The actual data access code that you need to write is minimal, since Entity Framework takes care of most of it. In fact, you can use Language Integrated Query or LINQ to perform most of your database queries. There's tooling available to keep your C# models in sync with your database tables, so you don't need to do this manually anymore. Entity Framework can keep track of changes made to your C# object instances at runtime, so it knows what changes to send to the database when it's time to persist the data. Also, Entity Framework Core supports multiple database providers, so you can use your same C# models with other relational databases if needed. Let's now see how to use Entity Framework Core to add database support to our Game Store REST API. The first step towards integrating our ASP.NET Core API with a database is the definition of our data model. The data model is going to contain all of the classes that we will use to create objects that will need to be persisted in our database tables. So let's start by going into our Solution Explorer. Let's collapse that. Let's right-click on GameStore.api, new folder, and let's name it Models. Now let's right-click in the Models folder new file. This is going to be a class. And let's name this one game. Great. Let's open our game.cs file. Let's remove that unnecessary using. And now let's start introducing all of the properties of our game model. The first one is going to be our ID. So let's define a public int ID with a getter and setter. Then let's define our public string name, which by the way is going to present this warning here because the compiler is demanding that we make sure that the name property always has a value after constructing an instance of the game class. One way to solve this is by initializing the name property as perhaps an empty string with string.empty. Another way to solve this is by making the name property nullable, right? So if you do this, it is a nullable object, so there's no need to have a value when the object is constructed. But we do want to actually have a value in the name property for a game because it will not make sense to have a game without a name. Because of that, what we can do is to actually use the required keyword here, required, which is going to make sure that whenever we create an instance of a game object, the compiler will demand that we provide a value for the name. Now, next we need to define our game genre. But at this point, we are no longer going to keep referring to the genre as a simple string. We will want to have our own table of genres in a database, and because of that, we need to define the genre as another class that has to be part of our data model. So let's go back into our Solution Explorer. Let's right-click on Models, New File, Class. Let's type here genre. Let's open genre now. Let's clean that namespace. And our genre is going to be a very simple class that is also going to have our public int ID and our public required string name. Both of them with a getter and a setter. So now we can go back into game and we can add our public genre. So this is going to be a composite property of the game model. Now, once again, we get the warning from the compiler demanding that we set some value for our genre property here because the type is not nullable right now. And in this case, we are going to make this type nullable by adding the question mark because as you're going to see across the course, there will be several situations where we will not want to have any value set for this composite genre property. And this is going to be the case when we only need to deal with the ID of the genre, but not with the entire genre object, when we want to perhaps query for our games. Now, just by having this navigation property in our game model that goes into the genre will be good enough for Entity Framework Core to understand that there has to be a foreign key from our game table and into the genre table. However, as a good practice, it is much better to clearly define here another property that represents that foreign key. So here we're going to define our public int genre ID. That way, Entity Framework Core knows that for sure we do want to have this foreign key from game to genre, but also it gives us the opportunity to have many scenarios where we can easily work directly with the genre ID without having to load the entire genre property when we want to retrieve games from the database, which is going to be much more efficient. We're going to see how we use interchangeably these two properties as we go through the implementation of our endpoints. Also, because the genre ID is not nullable, right? So this is not nullable. It means that the relationship here is going to require that we always have a genre ID associated with every game record. So the association is not optional, it is required, as it should be. Now let's complete our game model by introducing our public decimal price and our public date-only release date. And with this, our data model is complete and we're ready to start introducing Entity Framework Core into our API. To introduce Entity Framework Core into our ASP.NET Core API, we're going to need to use a new set of libraries that are not included by default with ASP.NET Core. These type of libraries are distributed as packages that are known as NuGet packages, and the place to find them is this page called nuget.org. This is the biggest repository of NuGet packages, and you should be able to find really any NuGet package that you ever need by just searching it here. Now, Entity Framework Core has support for multiple database providers. But for the purposes of this course, we're going to be using SQLite because it is very lightweight and very easy to work with when you're just learning how to work with Entity Framework Core. So to introduce the SQLite database provider for Entity Framework Core, the package that you want to use is this one called microsoft.entityframeworkcore.sqlite. Here you can click on search, and this is going to find all of the packages that correspond to that search string. Usually the very first one is the one that you want to use, Microsoft Entity Framework Core.sqlite. Click on that. And on this page, you are going to find many details about that package, including all of the latest available versions, and also the exact .NET CLI string to install the package if you want to use the .NET CLI. Now, this is one way to do it, but once again, since we are using the C# Dev Kit, there is a simpler way to do it directly from VS Code. So going back to VS Code, let's open up our Solution Explorer, Ctrl+Shift+E. Let's right-click on our GameStore.api project. Let's click on Add NuGet Package. And let's search for Microsoft.entityframeworkcore.sqlite. Hit Enter. Our package is the very first entry over here. Let's click on that. And here you're prompted to select which is the exact version that you want to use with your application. In this case, since our application targets .NET 10, we're going to pick the latest stable version for .NET 10, which is going to be this one over here, version 10.0.1. So let's click on that one, and the package has been installed. Now there is no clear visual hint that the package got installed, but if we open up our dependencies over here and our packages node over there, you're going to see that Microsoft Entity Framework Core shows up right here, which means that the package got installed. And also, if you click on the project itself, you're going to see that on the right side, we're going to go back into our CS_proc file, and we're going to find this new node, a package reference that represents the installation of the Microsoft Entity Framework Core SQLite package with the version 10.0.1. Great. So now we have Entity Framework Core support in our API, and we can start creating the objects needed to map our data model into SQLite tables. So let's close all of this. Let's go back into our Solution Explorer. Let's right-click on GameStore.api. Let's create a new folder that we're going to call Data. And inside Data, let's right-click and let's add a new file, which is going to be a class. And we're going to name it GameStore Context. Hit Enter, and let's open it in our editor. Let's remove the unnecessary using. And the purpose of this GameStore Context class is to act as your DB context, which in the world of Entity Framework Core represents a session between your API and the database and can be used to both query and save instances of the entities into the database. You can think of the DB context as a combination of both the unit of work and the repository patterns. Now, to actually turn this GameStore Context class into a DB context, we need to make it inherit from the DB context class that comes with Entity Framework Core. Here I'm going to do Control dot, so we can introduce the Microsoft.Entity Framework Core namespace. You also need to tell your DB context how to connect to your database. And you do that by passing in what is known as the DB context options. So here we're going to introduce a primary constructor that is going to receive DB context options of type GameStore context. And let's name the parameter as just options. Now let's send this to the next line. And let's pass in the options object into the base constructor. Several parameters, including the connection string, are going to be received as part of these options so that the game store context knows how to talk to your database. We will see later how to actually introduce a connection string into the application, but for now, this is how you declare your context. And the next thing to do is to actually define the properties that represent the mapping between your objects and the database tables. So for that, what you do is to define the following properties. We're going to do public dbset of game. And for that, we're going to do control dot here to use gamestore.api.models. And let's name this one games. Now, this is not going to have a getter and a setter, but instead it's just going to be a property that points directly into a set of game. So this dbset is really an object that can be used to both query and save instances of game in this case. And any link queries that you send to this games object are going to be translated into queries against the database. And just like we defined the set of games, we also want to define a set for our genres. So let's define our public dbset of genre, which is going to point to a set of genre. Great. So this is really all we have to do to define our DB context. But one more thing that we have to do is to actually register this DB context so that it can be used across our application. And to do that, let's go back into our File Explorer. Let's go into our program.cs file. And just like we added services for validation, we can also add our DB context by using the pattern that is known as dependency injection. Now, we're going to learn more about dependency injection later in the course, but for now, I just want to show you how to define the connection string to connect to the SQLite database and how to register your DB context with that connection string. So the first thing is going to be to define that connection string. So let's just define a variable here and make sure that you do this before the creation of your app object here. It has to be before so that it registers properly. So var constring. And here you want to use the correct syntax for a connection string that targets an SQLite database. So this is going to be data source equals, and on the right side of this equals, we want to specify the name of the physical file that represents the database. In this case, let's just name it gamestore.db. It doesn't have to be that name. It could be really any name, but it should be something that represents what the database is for. And now that we have defined the connection string, we can go ahead and register our brand new DB context with that connection string. For that, we're going to do builder.services.addSQLite. And here, as a type parameter, we want to specify our game store context, which, by the way, we're going to do control dot here to use gamestore.api.data. And then we're going to provide here the actual connection string. So con string. And with this, our application is ready to start talking to our SQLite database. However, we have not yet created the actual database file so that the application can talk to it. And to do that, we can take advantage of the Entity Framework Core migrations feature. A database migration is the process that incrementally updates your database schema to keep it in sync with the application's data model while preserving existing data in the database. In this case, we don't have a database, so we need to run a migration to come up with the initial schema of the database. But to do that, we're going to need two things. First, we need the .NET-EF tool that is going to provide the commands needed to kick off the migration. And for that, let's go back into our NuGet.org page over here. And in the search box, we can just search for .NET-EF. Let's click search. Should be the very first result over here, .NET-EF. And here we want to pick the latest stable version of the package, which right here it says is version 10.0.1 at the time that I'm recording this. So we are going to go ahead and copy this command line that we can see at the top. So let's copy that back into VS Code. Let's open our terminal, Ctrl J. Let's paste what we just copied. Notice that this is going to be a global tool, right? So this is a global tool. It has nothing to do with the current location of your project. Once you install it, it is going to be available for every single project in your machine. I'll hit enter. And the tool has been installed. The next thing that we're going to need is a new NuGet package. So let's close this. Let's go back into our Explorer, our Solution Explorer in this case. Let's right click on GameStore.api, add NuGet package. And the package that we're looking for is this one called Microsoft.EntityFrameworkCore.design. Let's hit enter. It's going to be the first one in the list, EntityFrameworkCore.design. Let's select the latest stable version, 10.0.1, and the package has been installed. And we can confirm that the package is there by going into Dependencies, Packages. Our package is right here. And we could also confirm it by going into the project file. We should be able to see the package installed right here. Now, the reason why we need this NuGet package is because it is essentially the tooling brain for EF Core. It gives the .NET EF tool the extra services needed to discover your DB context, build your model at design time, generate migrations, scaffold code, and a few other things. So now that we have .NET EF installed and the NuGet package, we can go ahead and generate our first migration. For this, let's open our terminal, Ctrl J. Let's clean this. And we want to switch into our GameStore API directory. So GameStore API. So to run the tool, what we do is .NET EF, migrations, add a new migration. Here we need to provide a name for this migration, which in this case is going to be the initial creation. So let's just name it initial create. And then I also find it handy to provide a location for the generated files. We can do that with -- output dir. And then we want to pick a location. Let's see very briefly our file explorer, Ctrl-Shift-E, to understand where we should generate this migration. Let's collapse this a bit. We probably want to go under our data dir, right? Inside the data dir, that's where we have our EF Core related files. So for output dir, let's enter here data, and then we will also add a migrations directory. Okay, so this is our complete command. Let's hit enter. And at this point, the tool is going to build our application, and then it is going to generate all of the database migrations files. Now, if we go back into our file explorer, we should see that a brand new migrations folder has been created. And if we open that, we're going to find a few files that represent the just generated migration. Now, among these files, let's actually look at the very first one, this one that ends in initial create. That, by the way, is going to have a number here that corresponds to the date and time when you generated this migration. But now if we open initial create.cs here, let's collapse this and this, we're going to see that this is going to be just another class that in this case inherits from migration that comes from EF Core, and that's going to have a couple of methods. First method is going to be the up method here. That is the one that has the logic to take your database from the current state and into the new state. And you can see here how we invoke the create table method here to define the creation of this new table in the database. This table is going to be our generous table. Here we define the columns that need to go into that table. And we also define the constraint here, which is going to be the primary key for our generous table. After having that table, we keep going, and now we create the second and most important table, our games table here. So we can see here's the games table. Here we can see all of the columns that correspond to that table that map to the game model in our C# code. But notice that this one actually defines all of the correct data types for the SQLite database. If we keep going down, we're also going to find the constraints for this table, which are the primary key for the games table and also the foreign key that relates our generate ID in the games table with the ID of the generous in the generous table. If we keep going down, we're also going to find the normal index that is defined on the column that was selected for the foreign key, in this case, the generate ID. And just like we have this up method, we also have the down method that is designed to take your schema back into the previous state. So if you ever need to get rid of one of your migration steps, this is the logic that would execute to first drop the games table and then drop the generous table. Notice that it follows the correct order to make sure that the steps are going to be completed successfully. And now that we have our migration files generated, it is time to execute the actual migration. And we can do that once again via the .NET EF tool. So let me just close all of these files. Let's go back into our terminal. I'm going to clean this. And let's run the following command. .NET EF database update. Let's hit enter. And this is the command that is going to take all of that migration code and run them in our machine to come up with the first version of our database. Now let me expand this terminal output for a moment, because we can see a bunch of lines here. And as you can see, what we have here is a bunch of SQL commands executed by Entity Framework Core to create our SQLite database. And I'm not going to go into every command in detail, but a few things to highlight here are the following. So for instance, here we have our EF migrations history table right here, which is going to be the table that keeps track of the latest migration that has been applied to your database, so that the next time that you execute a migration, it knows from which migration it needs to start. We keep going down, we're going to see that the actual migration is getting applied over here. So it is applying that migration that we just generated. And that means that it needs to do a few things, right? So it needs to go ahead and create our generous table right here. Here's a generous table. Then it needs to create our games table over here. And then it runs a few other commands to also apply the index, right? So the index for the foreign key. It adds our new migration into the EF migrations history table. And then it completes the migration. And because all of this executed, now we should be able to see, if we go back into our file explorer, and perhaps we collapse the terminal for now, we should be able to see that we have our brand new GameStore.db file generated right here. So our database is now alive and ready to go. And at this point, it is not a bad idea to actually explore that database to see if, in fact, the correct schema has been generated. And the way to do that is by installing a brand new VS Code extension. So let me open my activity bar for a moment. Focus activity bar. Let's go into our extensions view over here. And this time, let's look for the SQLite extension. It's going to be this one here. SQLite. Here's the author, as you can see right there, Alex CVCC. Very popular extension. It's very simple, but very handy to explore your SQLite schema. So let's click on install. Okay, it is installed. So let's close this. Let's get back into our file explorer. And now that we have the extension, what we can do is right click on GameStore.db. And we're going to find a brand new command right there that says open database, right? Open database at the top. Let's click on that. And that is going to bring in a brand new section on the left side that says SQLite Explorer. Okay. Now, before we go there, let me just hide my activity bar for a moment so that we can see better, and perhaps even my menu bar. And then let's expand SQLite Explorer. And what we're going to see is that our database is right here. And we can start expanding things to explore the schema of the database. So like I said, here we have our EF migrations history table, right? Here's the table that should contain the migration that we just executed. And to see what's inside of it, we can click on this play button over here to see the contents. And we can see that indeed, here's the ID of our migration. And we also have the version of EF Core that was used to produce that migration. Like I said, this is how EF Core is going to keep track of the latest migration applied so that it knows how to execute the next migration when it comes. We also have our generous table here. We can see the columns there, the ID and the name and the data types. And of course, we have our games table with all of the corresponding columns. Now, one thing that I find handy to do at least for local development, is to add some code at the startup of the application so that the latest migrations are always applied when the application executes. That way, we don't have to be running the .NET EF database update command every single time we prepare a new migration. So let me show you how to do that. Let's go back into our File Explorer, or actually our Solution Explorer, because we need to create a brand new class that we're going to place here under our data directory. Let's right click, new file. It's going to be a class. Let's name this one data extensions. Let's open data extensions.cs, clean that using. And this is going to be a static class because it is going to have an extension method that we're going to call public void or public static void migrate db. This method is going to extend our web application class app, and the code we're going to have here is going to be very straightforward. First, we're going to create what is known as a scope, which is needed so that we can get access to an instance of our game store context. Now, this is related to the dependency injection feature of ASP.NET Core that we will cover later in the course. So don't worry, I'll explain that more in detail later. But for now, let's go ahead and enter the following lines. We're going to go with using var scope equals app.services.create scope. And then we can retrieve an instance of the DB context by doing var DB context equals scope.serviceprovider.getRequiredService of type game store context. Perhaps I'll send this to the next line so we can see better, like this. And now that we have access to an instance of the DB context, we can do dbcontext.database.migrate. Once again, we get first a services scope that is going to give us access to retrieve or to create an instance of our game store context directly here in this migrateDB method. And then we use the DB context to access the database and to execute all of the pending migrations. Now to use this, we're going to go back into our program.cs file. So let's go back into File Explorer, program.cs. And this method we need to invoke after the creation of our web application object there. So let's do it perhaps here in my line 15. Before app.run, let's just call app.migrateDB. Now let's put our new logic to the test. And for this, let's go back into our File Explorer. And what I'm going to do is to just delete my GameStore.db file to see if it gets recreated automatically when the application starts, which is what our code should be able to do. So let's right click this. Let's do delete, and the file is gone. Now let's open our terminal, Ctrl J. I'm going to clean this, and let's just start the application. So I'll do .NET run, enter. And we can clearly see that the database file got automatically generated. So from here on, all we need to do is to add the new migration into our code. And when the application starts, it will be automatically applied to our existing database. Now, one other thing that I like to do at this point is to reduce a little bit the amount of logging that we get from EF Core every time this migrations code executes. Because as you can see, there's a lot of logging going on here, which is good to understand what's going on behind the scenes, but it is just going to be too verbose if we have to look at all of this every time we run the application. So to reduce this amount of logging, what we can do is the following. Let's just stop the application, Ctrl C, going to close my terminal, and let's go into our app.settings.json file. I won't be diving really into ASP.NET Core logging in this course, but one thing that you should know is that you can control the logging emitted by different parts of .NET and ASP.NET Core libraries by modifying the logging level right here in your app.settings.json file. You can see the default logging level over here is going to be of information level, and also the logging level for the libraries that belong into the Microsoft.ASP.NET Core namespace. And what we can do here is to also introduce our own configuration for the login level of the Entity Framework Core database commands. So here we can enter Microsoft.entityframework.core.database.command. And in this case, what we're going to do is to reduce the level so that we only see login messages with the warning level and above. So warning, error, and critical will be displayed, but nothing related to informational, tracing, or debugging messages. So I'll do warning here, and that should reduce the amount of logging that we see in the console. So let's try it out. Let's go back into our file explorer. Let's delete GameStore.db once again. This is why I really like SQLite to learn this, because it's very easy to delete the database. So it is gone. And now let's go back into our terminal. Let's run the application. And as you can see, all of those SQL statements are gone. They are executed for sure, but they are not presented in our logs because we reduced the amount of logging in the application. You can always change that later if you need to, but for the rest of the course, this should work just fine. Now it is time to start taking advantage of our new database across our different endpoints. However, before we can do that, we probably want to have some data in our new genres table, because if we take a quick look at the table right now, so let's go into SQLite Explorer, collapse this, and if we go into genres, let's just show the table. Let's collapse this and perhaps take it over here. We're going to see that, well, the table is completely empty. And because of this, we will not be able to create any games via our games endpoints, since the foreign key is going to demand that we first have something in the related genres table. So since in this course, we're not going to be creating endpoints to populate our genres table, what we can do instead is to seed our database when the application starts. We can seed it with a few initial genres that we can later use with our games endpoints. So let me show you how to do this. Let's close this. Let's also stop our server. And let's go now back into our program.cs file. Let me close all the other tabs. Go back here. Let's look for the section where we are adding our SQLite. It is right here. And what we can do is to use the additional options of the add SQLite method to also seed the database as soon as it is created. So let's do this. Let's actually send this into the next line. Let's do this. And let's add another parameter, which is going to be our options action. So this is a delegate that is going to provide the function to execute after the database is created so that we can populate the database. So let's do options. And here we're going to invoke the options.useSeeding method. Let's open parentheses. This is going to receive one parameter, which is going to be our DB context. So context. There's going to be another parameter here that we're not going to use. So let's just discard it with an underscore there. And then let's provide the actual logic here by opening and closing our curly braces. And the logic here is going to go like this. So if not context.set, which is going to give us one of the DB sets in the database context, and the set is going to be the genre set, okay, dot any, and before going forward, let's just do control.onGenre so that we can use our GameStore.api.models namespace. Okay, so if we are not able to find anything in the genres table, which should be the case when the database is just getting created, we are going to execute the following logic. We're going to say context.set genre.add range, and this is where we're going to introduce our initial game genres. So for this, we can do this. We can do new genre. Let's set a name. For instance, our first one is going to be fighting. And in the same way, we can introduce a few other genres. So I'm not going to type them manually over here. Let me actually just paste them from my cheat sheet over here. There. So now we have 5 game genres that are ready to be associated to any of our upcoming games in the database. Of course, we also have to remember to save these into the database, and we can do that by invoking the dbContext or context.saveChanges method, like this. Great. So with this, we should be ready to see the database when the application starts. So let's open our terminal once again. Let's open the terminal, let's clean this. Let's do .NET run. Okay, and now let's take a quick look at our database, Ctrl-Shift-E. Let's once again click here to see the contents of the genders table. Click there. And sure enough, if we take this over here, we can now see that our initial genders have been fully populated into the database. So database seeding is working as expected. Now, as with everything else, I would not like to keep this logic directly on program.cs because once again, it is getting polluted with a lot of logic that just makes the file much bigger and hard to understand. So let's do the following. Let's just stop my server here, and we're going to move all of this database logic into a brand new extension method so that we only have to invoke one line over here to kick off all of this logic. So for this, let's go back into Ctrl-Shift-E. Let's go into our file explorer, into data, and into our data extensions.cs file. Remember that this is the file where we have our migrateDB extension method. So it is also a good candidate to introduce a method to register our database services and our initial data seeding. So under this method, we're going to add a new one that we will call public static void add game store db. This one is going to extend our web application builder. And here what we're going to do is just bring in all of that logic, including our connection string, and all the way to here. Let's just cut all of this and bring it over here. Okay, let's select control dot here under generate so that we introduce our GameStore.api.models namespace. And the logic has now been completely moved outside of program.cs. Now we can go back into program.cs, and just after our add validation call, we can now call builder.addGameStoreDB. So a very clean file once again. We can even remove control dot, remove unnecessary usings to keep it cleaner. So things are looking good so far, but one thing to notice if you go back into data extensions.cs is that we keep this hard-coded connection string directly in our C# code. This is not really great because as soon as we try to move the application into a different environment, like for instance in production, we will have to completely change this connection string directly in the code so that it can get deployed to production. And if we need to go back to development, we'll have to change it back to this local connection string, and that's not going to be great. It's really error prone and problematic. So let's make a pause here to learn more about the ASP.NET Core configuration system and how it can help us with this hard-coded connection string. At this point, we have hard-coded the connection string to talk to our database directly in our application code. However, this is not ideal since eventually when we move the API to a different environment, like in a cloud deployment, the connection string will be different and we would need to make extra code changes. Fortunately, there are better places to store application configuration. One of the most popular options in ASP.NET Core, especially for local development, is the abstract.json file, which can store all sorts of configuration information in JSON format. Now, the abstract.json file is what is known as a configuration source. And just like that one, there are several other configuration sources supported in .NET applications, like command line arguments, environment variables, user secrets, and even cloud-based configuration sources like Azure Key Vault. And the great thing about this is that the ASP.NET Core runtime takes care of combining information from all available configuration sources into a single configuration object that implements the iConfiguration interface. This configuration object is easily accessible to your REST API in such a way that it doesn't really need to know where the configuration data actually comes from. In this tutorial, you will use the absence.json file to store your connection string. But keep in mind that this is an acceptable option only because you don't need to use any credentials to connect to your SQLite instance. If, for local development purposes, you are using a database server instance that requires credentials, please use the user secrets configuration source instead, which is enabled by the ASP.NET Core Secret Manager. Never store any kind of credentials in your absence.json file. Let's now update our REST API to read the connection string from absence.json. Let's see how to use the ASP.NET Core configuration system to stop hardcoding our connection string in our C# files. So let's start by going into our absence.json file over here, and let's collapse this. And the way that we can introduce our connection string here is by using a well-known key in this file. So let's open here one more section and let's name it connection strings. Let's open this section and we can introduce our connection string as a key value pair. Now, since this is the connection string for the game store database, we can use something simple as game store as our key. And then for the value, we want to introduce the same connection string we've been using in the code so far. So let me do Ctrl+Shift+E to go back into our data and data extensions.cs file. Remember that our connection string is currently living here in our addGameStoreDB method. It's right here. So I'm going to copy it. And I'm going to paste it over here. So that's how you store your connection string in configuration so that the ASP.NET Core configuration system can easily read it. But of course, now we have to make changes in data extensions.cs so that we can use this configuration system. For that, all we have to do is the following. So here, let's replace this with a call to builder.configuration.getConnectionString. And the parameter to this method is going to be the key of the connection string that you just defined. So going back to absence.json, that key is going to be game store. So let's copy that key. Back here, let's paste it right there. And let's finish this line. That's really all you need to do to read your configuration from absence.json. And to prove that this works, let's perhaps place a breakpoint here in my line 19. Let's start the application and let's see if we can actually read the connection string from there. So I'm going to hit F5. Here we are. Let's collapse this and perhaps this. And if we go and hover over constring, we're going to see that indeed the connection string has been read from absence.json. So there's no need to keep hardcoding that connection string here anymore. I'll click on play and the application would start normally. However, the power of the configuration system is that you can now start overriding that connection string as needed in any other environment, like in a production environment. And to show you how that could work, let's do the following. Let's just stop this debug session. Let's open our terminal. Let me switch to an actual terminal here. Open a new terminal. Perhaps let's kill the other one. And let's do the following. Let me maximize this. We're going to define now the connection string as an environment variable. Since I'm using PowerShell here, the way I can do this is by specifying an env call here with the name of the environment variable. Now, what name to use here? Let me actually collapse this for a moment because the name is going to be in absence.json. ASP.NET Core is able to follow a well-known hierarchy of names to map things into configuration. So in this case, I can start the name of my environment variable with the connection strings word, like this. Then I'm going to separate that key from the child key by using double underscore. And then we can place the next name in the configuration key, like this. Then I'll do equals. And then we want to place the actual value, right? So I'm going to copy the value over here. But this time, and to prove that this is actually going to work, I'm going to change the name of the database. So let's imagine that we are now in production, and in production, we are setting an environment variable for a different database. Let's name it production.db, and I'll hit enter. So if this works, we should end up with that new database when we try to run the application, this time with a simple call to .NET Run. So let's switch into our GameStore.api directory. And before executing .NET Run, let's perhaps open our file explorer so that we can confirm that so far our database is still named GameStore.db. But now if we execute .NET Run while having this new environment variable set here to override configuration, so we are going to hit enter. And what we can see is that a brand new database, our production database, is now getting created because the application now believes that this is the new value for our configuration. Notice that it even applied the migration once again. It is a new database. So just by setting that brand new value in the terminal as an environment variable, we were able to completely change the configuration without ever having to touch our C# code. The C# code is the same as you saw, exactly the same code that is reading the configuration. It doesn't know really where the configuration is coming from. And this is what makes the ASP.NET Core configuration system very powerful and flexible so that the same code can work across many environments. Now, since we set this environment variable in my current terminal session, it will be gone as soon as I kill that terminal. And to confirm this, let's go back and open our terminal. Let's do Ctrl+C to stop the application. Let's just kill this terminal completely. Let's go back into our file explorer and let's just delete that new production.db file that we created. Delete, it is gone. And now if I reopen my terminal, let's go into GameStore API, .NET Run. The application is now going to start, but now it is going to read once again from our app-settings.json file, right? It's going to read from here because there's no more environment variable. And we can see that on the left side, we are back into GameStore DB. There is no production DB created anymore. And with this, we are done with the configuration part of the application. And it is time to start taking advantage of our new database across our different API endpoints. But before doing that, we need to learn a very important concept in ASP.NET Core, which is known as the dependency injection system. So let's make a pause here to go and learn more about that. To understand what dependency injection is, let's start by looking at two classes, myService and myLogger. myService uses the logThis method of myLogger to log messages to a file anytime myService performs an important operation. Since myService uses some of the functionalities of myLogger, like the logThis method, we say that myLogger is a dependency of myService. Now, in order for myService to start using myLogger, it creates an instance of myLogger in its constructor. And after that, it can start calling the logThis method. At first glance, it doesn't look like this presents any problems. But consider what happens when the authors of myLogger decides to slightly modify it so that a new myFileWriter object needs to be passed on its constructor, because that's where the output file is now defined. The required changes look simple to implement, but they reveal a few important problems. myService is tightly coupled to myLogger in such a way that anytime myLogger changes, there's the need to also change myService, as it happened here when the constructor started requiring a myFileWriter instance. myService needs to know how to construct and configure the myLogger dependency, like is the case here with the myFileWriter object, which needs to be configured with an appropriate file to send the output logs. This makes it hard to test myService since unit tests won't be able to mock or stop myLogger. An output.log file will always be created, which would slow down tests, and this assuming that the tests have access to a place to write files to. Fortunately, there's a better way to do this using what is known as dependency injection. Let's go back to myService and its myLogger dependency. myService still uses the logThis method, but this time myLogger is not explicitly constructed by myService. Instead, myLogger is passed in as a constructor parameter. This way, my service doesn't need to know how to construct or configure the logger. It just receives it and can start using it right away. But if my service doesn't construct the logger, who does it? Well, ASP.NET Core provides the iService provider, which is what is known as a service container. Your application can register my logger and any other dependencies with iService provider during startup, which is typically done in your program.cs file. Then later, when a new HTTP request arrives and your web app needs an instance of my service, the service container will notice its dependencies and it will go ahead and resolve, construct, and inject those dependencies into a new instance of my service via its constructor. This enables multiple benefits for your application. To start with, my service won't be affected by changes to its dependencies. It doesn't matter how many times the constructor of my logger changes. There is no need to change my service. Moreover, my service won't be creating instances of my logger, so it doesn't need to know how to construct or configure it. And if your application uses minimal APIs, dependencies can also be injected as parameters to your API endpoints. But when should iService provider create new instances? We know that on startup, your application will register the dependencies like my logger here, and later, when an HTTP request arrives, iService provider will resolve, construct, and inject an instance of my logger into a new instance of your class, my service in this example. What is not clear is what happens when a new request arrives. Should iService provider create a brand new MyLogger instance for the new request? Or should it reuse the same instance? What if another service that also has a dependency on MyLogger needs to be created in response to a new request? Same MyLogger instance or new MyLogger instance? The answer to this lies in the service lifetime. In other words, how long each instance is supposed to live. There are 3 service lifetimes: transient, scoped, and singleton. But for now, let's focus on scoped because that's how you are registering your DB context in your application. Let's say that my logger is a class that keeps track of some sort of state that needs to be shared across multiple classes that participate in an HTTP request. In that case, you would register my logger with the addScoped method. Here, when an HTTP request arrives, the iService provider will resolve, construct, and inject a new instance of my logger into my service. But if there is any other service that participates in that same HTTP request and that also has a dependency on my logger, it will receive the exact same instance of this dependency. However, if a new HTTP request arrives, the service container will create and inject a brand new instance of my logger instead, totally related to the previous instance. So scoped lifetime services are created once per HTTP request and reused within that request. Now let's go back to the code and see the scoped lifetime in action by injecting the DB context into our API endpoints. Let's see how to start using our DB context with our API endpoints by taking advantage of the dependency injection system. So let's go into our endpoints and games endpoints, and let's collapse this for a moment. And let's start with our post endpoint, the one that creates games. So let's scroll down into our map post call over here. To introduce our DB context into this endpoint, all we have to do is to add it as a new parameter in our handler. So after our new game DTO there, we can add game store context, DB context. Let's do control dot here so that we can use our game store.api.data namespace. That will make it so that the service container resolves, constructs, and injects a new instance of game store context into this endpoint. But where was this DB context actually registered? For that, let's go back quickly into our program.cs file. And remember that we have this call here called add game store DB. I'm going to click on this one and I'm going to do F12 to see what's going on there. Here we're going to remember that what we do after just retrieving the connection string is making this call into add SQLite of type game store context. This is the exact moment when we register our DB context with the service container in preparation for dependency injection. And one thing that you should realize is that making that call is not too different from making something like builder.services.addScoped of game store context. So add SQLite here is registering our DB context with a scoped service lifetime, the same way that addScoped would do. But why would we want to register the DB context as a scoped service as opposed to a singleton or a transient service perhaps? This is something important to understand, so let's talk about this for a moment. Let me actually remove this, and I'm going to add a few comments here to explain this. Now, our DB context has a scoped service lifetime because the scope lifetime is going to ensure that a new instance of the DB context is created and disposed for each request. If you go back briefly into game's endpoints, what you need to understand is that anytime in this case, your map post endpoint is invoked, a brand new instance of game store context is going to be created, and it's going to live only until we reach the end of this method. As soon as we get out of this map post endpoint, that game store context is going to be destroyed. And when a brand new call to map post or to any other endpoint comes in, a new instance of the context will be created. But what is it that we want it that way? Well, that is because database connections are a limited and relatively expensive resource. So the scope lifetime of the DB context is going to ensure that the connections are opened and closed efficiently. The DB context is not thread safe. So having a single instance of DB context across multiple requests could lead to concurrency issues. By having a separate DB context instance per request, it is easier to manage transactions and ensure data consistency across a single unit of work without interference from other requests. And also, reusing the same DB context instance across multiple requests can lead to increased memory usage as the context tracks changes to entities over its lifetime. So by using a scope lifetime, we ensure that each DB context is short-lived, which reduces memory overhead and potentially improves performance. So these are the main reasons why the DB context is registered with a scope service lifetime, and you should keep this in mind as you work with the DB context across your API endpoints. Now let's go back into our game's endpoints and see how to actually use this DB context. And the first thing to do here is to create a new instance, not of our game DTO as we're doing so far, but of our new game model, which is the one that we're going to use to store into the database. So let's delete all of this, and instead let's create our game by doing game, and for this let's just do control dot here so that we can introduce our game store.api.models namespace. And this is going to be our new instance there. And here the first property to specify is actually going to be our name. So we can do name equals new game.name. And notice that we don't specify the ID, and that is because the database provider is going to be in charge of auto-generating a unique identifier for the game as soon as the game is created over there. Next, we want to specify our genre ID, which would be our new game dot genre ID. However, as you can see, we don't have a genre ID just yet in our create game DTO, right? It is just genre, and this is something that we do need to change. If we go back into create game DTO, we will remember that here is how we define our genre, and this is not really going to work when our front-end clients send a post request to our endpoint, because what they want to send is the unique identifier of the genre that was selected in the front-end UI. So let's change this into an int genre ID. And for our data annotation, let's change all of these perhaps into a valid range for our genre. So let's say it's going to be a range of 1 to, let's say, 50, so that we could have potentially up to 50 genres at least to start. And with that, let's come back to games endpoints. And now we can define here new game dot genre ID. And let's keep moving with our price, which is going to be new game dot price, and our release date, which is our new game dot release date. So that defines our game model to insert into the database. But how do we actually insert it into the database? Well, that's going to require the use of our DB context. So instead of this, we're going to do DB context dot games dot add, and here we provide our new game. However, just keep in mind that this line does not actually send the game into the database. It only asks Entity Framework Core to start keeping track of the fact that a new game needs to be inserted into the database. To actually make the call to the DB so that the game is saved, what you want to do is dbcontext.save changes. This is going to translate any pending changes in the DB context change tracker into SQL statements that the database is going to understand. So with that, the game will be saved, but of course we still need to return something back to the client. And as we can see here, our created@route method here includes our game instance over here. However, at this point, this is not ideal because remember that game here is no longer a DTO. It is our actual game model that was just stored into the database. And as a good practice, we never want to expose the internal details of the system to our callers, to our clients, because that's going to make it challenging later to change our internal data model without breaking our clients. So instead of keep returning our game object, what we want to do is to return once again a DTO. Now, what DTO to use here? Well, it could be the same one that we were using before. So let's take a quick look at that. Let's go into DTOs. And the one that we were using before was the game DTO. This is the one that we were returning. However, this one is not quite going to work for this because, as you can see, it does include the genre as a string as opposed to an integer, a number. So instead of using this, we're just going to leave it there for now. And let's go ahead and create a brand new DTO. So I'm going to copy this and I'm going to paste it right there as a copy. And we're going to name this new one as game details DTO. Okay, so this is game details DTO. Let me remove this. Let's collapse this and do the proper naming here, game details DTO. And of course, the difference is that this one is going to return here an int genre ID. And now that we have this, we can go back into our game's endpoints. And after our save changes call, we can define game details DTO. Let's call it game DTO. It's going to be a new. Okay, let's open and close our parentheses. And here we want to provide our game.id, which, by the way, at this point, just after calling save changes, this ID will already have the auto-generated value for the game ID. So it is valid to start using the ID at this point. Then let's provide our game.name, game.generateID, game.price, and game.release date. Then let's copy this game DTO instance. Let's just copy this and let's use it for our created@route call here. Let's put it over here instead of game. And let's also include it as the body of that post request return. So we'll use it right here, game DTO and game DTO. And with that, our post endpoint has been completely converted into actually using our DB context to start storing games into the database. So it is a good time to try this out. Let's open our terminal. So I'll do Ctrl J here. I'm going to switch into store.api. I'll do .NET run. Okay, let's close this for a moment and let's open our games.http file. Let's remember that over here we have our post call, right? So this is the post call to create a game. But of course, the problem with this is that so far it is using still the genre as a string, right? So it says platformer here. And as we know, this is something that we can no longer do. We need to provide the genre ID. So this should be genre ID. But what ID to provide here? Well, we need to figure out this by taking a quick look at our database. So let's right click on gamestore.db. Let's select Open Database. Let's go into our SQLite Explorer. And let's click on the play button here to see the contents of our genres table. Okay, so on the right side, we can see our current genres in the database. And the platformer genre is actually assigned the number 3, right? So platformer is number 3. So let's use that number 3 to create our game. Let's close this. And let's put the number 3 right here. I'm also going to collapse this for a moment. Let's also update our price here. This is too expensive, like that. And now let's send a request and let's see if we can create this game into the database. So let's click on send request. And sure enough, the request was successful. We can see that we got our 201 created. We can see generated game down here. And very importantly, as I said, we can see that a unique identifier was generated for our game that was provided by SQLite. We didn't have to specify it. It is a standard behavior of many databases to automatically generate an ID for your records following a sequence. Now, we may want to confirm that the game actually exists in the games table. So let's close this, Ctrl-Shift-E. Let me go back into our SQLite Explorer. Let's click here in the arrow for the games table. Let's click there. And if we collapse this for a moment and perhaps move this over there, we can see that the game indeed has been created into the database. So our post call was indeed a success. Now let's close this. Let's go back into our game's endpoints. And before we start moving the rest of our endpoints into also using the game store context, there is one more concept that we need to learn, and that is the asynchronous programming model. So let's pause here for a moment to learn more about asynchronous programming. To understand asynchronous programming, let's go through a common scenario, making breakfast. Let's say you start by heating your pan for a few minutes, and then, when ready, you fry some eggs there. We would also like to have some bread for our breakfast. So after our eggs are ready, we bring up the toaster and toast our bread. Then, when the bread is ready, we add some jam or peanut butter on it. Finally, our breakfast would not be complete without some juice. So let's pour in some orange juice. In total, it took us about 30 minutes to complete our breakfast. But is that really how you would go about preparing your breakfast? If it is a weekday, when you are usually in a rush, perhaps you would do this instead. You start heating your pan, and while that happens, you will also start toasting your bread. And while those things happen, perhaps you can also pour your orange juice. Eventually, when the pan is ready, you go back to it and fry your eggs. And once the bread is toasted, you go back and put the jam or peanut butter on it. Doing things this way, you can be done in much less time, say 15 minutes. And perhaps you can spend the rest of the time enjoying your breakfast. When comparing these two ways going about making your breakfast, we say that the first approach is synchronous, since you won't start a new task until the previous one is complete. However, the second approach is asynchronous, since you don't wait for a task to be complete before starting your next task. Here, you start as many tasks as you can, and eventually you turn your attention to tasks that are ready for you so you can continue with the next task. In a similar way, you can perform asynchronous programming in your ASP.NET Core applications. When a client sends a request to your web server, you want to start handling the request in your endpoint in an asynchronous way, so that your cook, the Kestrel web server, is immediately free to start handling the next request. So as your endpoint starts an asynchronous call, perhaps to your DB context, and the DB context in turn requests data asynchronously from the database, the web server has also started serving the next request, also asynchronously. When the database eventually returns the requested data, the DB context will resume work and send the data back to the endpoint, which in turn resumes work, transforms entities into DTOs, and sends the data back to the web server, who in turn responds to the original client request. After this, the application continues starting other tasks asynchronously and resumes work whenever necessary. As you can see, the asynchronous programming model brings in multiple benefits. Your application gets improved performance since you avoid blocking callers and free them up to perform other tasks, which also results in overall better responsiveness. You're able to scale your application better because it can handle multiple requests and users simultaneously without getting bogged down by waiting for I/O operations to complete. And also, the use of task objects in combination with the async and await keywords provide a simple and intuitive way of writing asynchronous code as opposed to having to deal with threads and callbacks directly. Now that you understand the asynchronous programming model and its benefits, let's see how to put it to work in our current ASP.NET Core application. One thing that we need to understand about the way that we have implemented our API endpoints, like our post endpoint over here, is that the .NET Runtime is going to allocate a thread for the execution of this endpoint, right? So everything that is coded in this endpoint will run in a thread. And when you run this way, which is the synchronous way to run the code, that thread can never be returned back to the runtime so that the runtime can do something else with it, right? So the runtime is locked into us completing all of this code before that resource can be returned. So this is why we want to switch into the asynchronous programming model so that we only do as much work as we really need to do, and we return any available resources back to the runtime so that it can do something with it until we're ready to keep going with our code. So for instance, in this method, let's take a look at this line here, line 60, where we call save changes. This is the line where we talk to the database to send it all of the SQL statements needed, in this case, to save our game. This is a situation where we need to get out of our process, our .NET process, and reach into an external resource, which is the database, which could take some time to respond. In the local box, it's likely going to be fast, but in production, it could be a database hosted in the cloud, and that's going to take some time. And while all of that happens, like I said, that thread, the resources of that thread cannot be returned back to the runtime. So we want to switch this into the asynchronous programming model to release those resources. Now notice the return of save changes. Right now it returns just an int, which is a number of records that in this case will be stored in the database. And what you'll notice with many methods like this is that there's usually going to be an async version of the method, like this one, save changes async, that is no longer going to return just a number, but instead is going to return something different, which is going to be a task, right? A task of type int in this case. That opens the door for receiving not just a synchronous number, but receiving a task that can be waited for, and that when it completes, we can continue doing some other work. Now, because this now returns a task, we cannot just continue running the rest of the code like it is right now. Because when you invoke this method, you're no longer waiting for everything inside that method to complete. You're just asking it to start doing the work. It returns immediately with that task, and then it keeps going with the rest of the code. And if you don't wait for it, it means that we are already running this code and even returning a result before the changes are stored into the database. So one way to deal with this would be, for instance, and there are a few ways, but one way is that you could do dot continue with, right? And then you could open an expression here that's going to receive the task. And then you can open a Lambda expression here where you're going to actually write the code to continue your logic, right? The logic that we have down here, which I'm not going to paste there to not complicate things. But this would be one way to say, hey, go ahead, save changes, and when all of those save changes steps are completed, please come back and let us complete the rest of the code. And in that interval, the resources allocated to our endpoint are going to be returned to the .NET runtime, and then we'll get back those resources when we are ready to continue. Now, we could do things this way, but this is really an older way to deal with tasks. There is a much better syntax using the async and await keywords. So let me return this to this other signature. What we want to do is to specify that we do want to await on this execution, right? We want to await on the execution of the task. But for this to work, we have to combine it with the async keyword. So if we go all the way up here, at the start of our handler, what we want to do is to introduce here async. By doing this, we are telling the compiler that not just we want to make a call to an async method like save changes async, but we want the entire endpoint to run in an asynchronous way. That means that we are telling the compiler and the runtime that there's going to be some asynchronous code happening here so that it should be ready to release resources whenever we have to do things like save changes async, which can take some time. And in that time, the runtime will want to do something else before giving back control to our method so that we can continue this logic over here. So as a best practice, always look for the async version of your methods, like this one here, save changes async, and always use the async and await combination to mark the fact that you want to run things in an asynchronous way. Now that our post endpoint is ready, let's also make the changes to our get by ID endpoint, this one over here, so that it can also use our DB context and it also operates in an asynchronous way. So let's start by introducing our DB context here as another parameter, game store context, DB context, so that it is received via dependency injection. Let's introduce the async modifier here at the start, and then we're ready to retrieve that game from the database. So instead of doing this, what we're going to do is the following. We're going to say await DB context dot games dot find async, and then we're going to provide the ID of the game. And the rest of the logic is going to be similar, right? So if the game is null, it means that it is not in the database, so we return a not found. But otherwise, we found the game and we are ready to return the response. However, we have the same problem that we had before with this response because this game object here is an internal representation of our games in our database. And we don't want to be returning that internal representation. We always want to return the corresponding data transfer object or DTO. So let's remove this and instead let's return a new game details DTO, which is going to receive our game.id, game.name, game.genere_id, game.price, and game.release date. And that should be good enough for our getById endpoint to be able to retrieve games from the database. So let's try that out. Let's open our terminal. Let's do .NET run. Okay, let's close this. Let's go into our games.http file. And we did create a game already, right? So we did create this game. So we should have a game with an ID of 1 in the database. So let's update our second endpoint here with number 1. Let's click on send request. And as expected, now we are able to receive that game. We have a 200 OK, and we have the game body down here with the expected response. So now we have a way to both create games and retrieve a game by ID from the database, not only using EF Core, but also using the asynchronous programming model. Now let's see how to update the endpoint that can retrieve us all of our games, right? The one that responds to this very first request over there. So let me open my terminal and let's just stop my server. Let's go back to games endpoints. And of course, the endpoint we want to modify now is this one over here. So as usual, we're going to start by introducing our game store context, DB context here, dependency injection. Then let's make our method asynchronous by introducing the async keyword here. And then we're going to update this expression, the handler that we have defined here, so that it no longer returns games, but instead it's going to do the following. It is going to do an await of dbContext dot games. And from there, we're going to project the elements to return to the client. We don't want to just return the games themselves because, like I said, we don't want to return internal details of how we store games in the database. We want to return the DTO version of those. And for that, what we can do is just make a call to select. And here we will project our game into a new game DTO. Now let's open our parentheses here. And we'll need to start providing our values, right? So we will provide our game.id, our game.name. And for the case of this specific DTO, we do want to specify the string version of our game genre as opposed to the genre ID. And this is because we expect that the frontend that is going to invoke this method is not really going to care about specific IDs for the game genres, but instead just a string version will be just enough. Now, how do we get the genre ID? So what we can do is the following. We can do game.genre.name. So we access the composite property. Remember that genre here is of type genre. And from that composite property, we can get access to the name. Now, we do see a warning here. As we can see, there is a warning that is about nullability on the genre. And this happens because we declare the genre as nullable, and the compiler is concerned about us trying to use something that could be null. Now, it is perfectly valid to have the genre null sometimes because, as we saw, there are times where we don't really need that genre composite property. For instance, here in our getById endpoint, all we use is the game genre ID. And when we construct a brand new instance of the game in the post endpoint over here, again, all we use is the genre ID because that's enough to satisfy the foreign key property, right? However, there will be cases like this one over here where we do want to access that property and then get access to the properties inside that composite property. Now here, there are two things that we have to do. The first thing is to ask Entity Framework Core to actually load the genre from the database when the query is sent into SQLite in this case. If we don't do that, then the genre is just going to come as a null value there, and then, well, this is going to crash. So to ask Entity Framework Core to load associated entities, what you do is just invoke include, and then you specify what is that you want to include in that response from the database. In this case, it's going to be game.genre. So now EF Core will include the genre as part of the response that we're going to get. Now, unfortunately, the compiler does not just understand that we for sure are going to get a value right here via this include. So it keeps complaining. And this is one of these cases where you can actually take over the behavior and tell the compiler that you don't really care what it thinks about what could happen here. We know that genre should not be null in this case. Because of that, we can use the null forgiving operator, the exclamation point that you can see over here. We will use that to tell the compiler that it doesn't have to worry about it because we know that genre should come with a value. Okay, so now let's just complete the other properties needed here. We need to provide our game.price and our game.release date. Now here the compiler is complaining with these red squiggles because the return of this query here is not asynchronous. So we need to turn this response into an actual asynchronous response, something that returns a task. And for that, what we can do is just after our select call here, we're going to add a line and we're going to do dot toList async. By doing toList async, we turn the iQueryable response from this link query over here, we turn it into a task of list of game DTO in this case. And that should work, but a good practice here is to ask Entity Framework Core to not keep track of the results that are going to be coming back. By default, it does want to keep track of all of those returned entities in case you are going to make any changes to those entities and save them back to the database. But as you can see here, all we're going to do with this is just talk to the database and return the values, right? There's no more logic going on here. Very simple. So to improve performance here and to ask EF Core to not keep track of those entities, all you have to do is just say as not tracking. And now the EF Core tracker is going to be turned off for the response of this, and the query is going to be essentially faster. Now, before trying this out, one more thing that I'd like to do is to actually rename our game DTO here, because now we have both game details DTO and this game DTO. And I'd like to be a bit more clear on what this game DTO is about at this point. So let's do Ctrl Shift E to open our file explorer. Let's go into our game DTO. And what I'd like to do is just to rename game DTO into game summary DTO. That's going to be the new name, game summary DTO for the file. And for the actual record type, I'm going to do F2 and output here game summary DTO, enter. Okay, so back into games endpoints, we should see that the new name is being used right here and anywhere else in this file. Now let's try this out. So let's open our terminal, Ctrl J. I'm going to start my server. Okay, let's close this. Let's go back into our games.http file. And to make our response a little bit more interesting, I think we should add at least one more game so that we don't get a response of just one when we want to see multiples, right? So I prepared another payload for our post method that I'm going to paste right here, like this. So now this is Street Fighter 2 with genre 1, which should be our fighting genre. Here's the price and here is the release date. So now let's hit send request. Okay, so the game got created, right? It was a success. Created. Here we can see that it got assigned ID number 2 and genre 1. So now we can try our get all games endpoint, the very first one in our file. Let's click on send request. And we can see that we got a successful response right there, 200 OK. And we can see the response of the method that is now bringing back both of our games, right? So here we have Super Mario Bros. Wonder and our Street Fighter 2 game. Notice that even when the genres are stored as IDs in the games table, in this case, we were able to pull out the actual string version of the genre, both for Super Mario Bros. Here and also for Street Fighter 2. Now let's continue with our next endpoint, which is going to be the put endpoint. So let's stop our server. Let's close this. Let's go back into games endpoints and let's look for our map put call over here. As usual, let's start by introducing our game store context object over there, our DB context. Maybe I'll send things to the next line so we can see better. Signature is a bit long. Then we will make the method asynchronous by introducing, as usual, the async keyword over here. Then for the implementation, we will no longer do this. And instead, we're going to do the following. We're going to do var existing game is going to be a await of db context dot games dot find async, and we will provide our ID. That's how we're going to find the game. But of course, it may be the case that we cannot find the game, right? So that's when existing game would be null. And in this case, we have to do something just like we tried to do here before. What we're going to do in this case is just check if existing game is null. We will keep returning our results that not found. Moving on, we're going to update that game that we just found, existing game. It has to be updated with the new properties of the incoming DTO. So we will do existing game dot name is updated game dot name. Existing game dot genre ID is updated game dot ideally genre ID, but as we can see, we don't have the genre ID available in the updated game DTO. Similar case as what happened with our post endpoint. So let me just do F12 here to go to our DTO. And this is the moment to make that same change that we made with our create game DTO over here with the genre. Perhaps we can actually take a quick look at our create game DTO so that we're going to bring that same property with the same restrictions that we have set so far. Okay, I'll close this. I'll go back to update game DTO. I'll switch this into genre ID with a range of 1 to 50. With that, let's get back into games endpoints and let's use our new genre ID property. Now let's complete this by doing existing game dot price is updated game dot price, and finally existing game dot release date is updated game dot release date. And the last thing to do here is going to be to actually ask if core to send these updates into our database. And for that, all we do is await dbcontext dot save changes async once again. And that is really all we have to do to prepare our endpoint for real updates into the database. Now let's try this out. So let's once again start our server. I'm going to start it here. Okay, let's close this terminal. Let's go back to games.http. And then of course the method that we want to use this time is our put request over here. Before making any changes, let's just remember quickly what is that we used to create our Street Fighter 2 game, which is of course the contents of our post request. So let me actually copy our post body over here. Let's use it as the base for our put request. I'll paste that here. Let's make sure that we update the ID of the game, right? So this is not game 1, this is going to be game 2, right? That is Street Fighter 2. And well, for the actual update, let's make it so that this is going to be Street Fighter 2 Turbo. And the price this time is going to be just more expensive, right? So $19.99. Now let's send a request. So send request. We got our 204 no content, which means that it was a success, all good. And well, let's just confirm that the update actually happened by going back into our get by ID endpoint, this one over here. Let's use number 2. Let's click send request. And as expected, we get the updated name, Street Fighter 2 Turbo, and the updated price. So the update was a success. Now let's move on to our last endpoint, our delete endpoint. So let's close this. Let me stop my server. Back into games endpoints. We are looking now at our delete endpoint over here. And as usual, we can start by introducing our game store context, dbcontext. We make the method async. And to remove the game from the database, there are a couple of ways. But I think the most efficient one is the following. We're going to do await dbcontext.games. And then we're going to be using the where clause. We're going to say where game.id equals ID. So that's going to filter all of the games until we find the specific game that we want to delete. And from there, we can invoke the execute delete async method over here, which is the one that is going to kick off that deletion from the database. Now, this pattern here that I'm using is what is known as bulk deletion. So it deletes all of the games that match this specific filter that I specified here. It is not the only way, but I think it is very efficient because it only requires a single round trip to the database to perform the deletion if it is able to find the requested game. Just understand that in this case, there is not going to be a save changes call, right? So there's no save changes async call because this happens at once, right? It's just one call to the database that executes the deletion. And after this line, the game is gone if it ever existed. Okay, so let's try this out by starting our server one more time. Okay, I'll close this, go back to games.http. And to test it, and since I don't want to actually lose any of my existing games, what I'm going to do is just add a test game. So let's just call it test game. Okay, the rest of the details are not going to matter really. I'm going to click send request to post this game. Okay, so the game got created, right? And it is game number 3, right? Game number 3, we can see the location of game number 3 over there. Let's confirm that the game is in fact in the database by using our second request. Let's find that game. Yep, it is right there. So now let's go ahead and delete it by going into our last endpoint here, our delete endpoint. We're going to do this for game number 3. Let's click on send request. We get our 204 no content, meaning that this was a success, the game was deleted. And let's just confirm that by going back into our get by ID request, once again for name number 3. Let's click on send request. And of course, we get our 404 not found because the game is now gone. And that completes the implementation of our games API. But before moving to the next thing, let's just go into our games endpoints. And let's remember to also clean up the very start of this file because we have still this games array that is completely useless now. So we can now just select all of this, okay, and delete it, keeping only the definition of our actual endpoints that talk to the database. Our games API is complete. At this point, we have completed all of the CRUD endpoints for our games API. However, we still need one more endpoint, not for games, but for games genres. Because our frontend is going to need some way to display in the UI the list of all of the available game genres so that the user can select one in the game creation screen. So let's use everything we have learned across this course to quickly spin up a brand new endpoint that can retrieve all of those game genres. Let's start by going into our Solution Explorer. Let's collapse this. Let's go into our project here. Let's go into DTOs, right click, and let's add a new file, which is going to be of type record. And let's name this one genre DTO. Let's open that. We're going to remove the class modifier here. And this is going to be a very simple DTO that all it's going to have is an int for the unique identifier of the genre and then a string name. This is the DTO that's going to be used for the response of our new endpoint that's going to retrieve all of those game genres. Now let's implement the actual endpoint. So let's go back into our Solution Explorer. Now into our endpoints folder, let's right click, new file. This is going to be a class. Let's name it genres endpoints. Let's open up here, collapse. Let's remove that unnecessary namespace. This class has to be static because it has static methods that are going to be extension methods. And let's declare that method here. It's going to be a public static void map genres endpoints, which is going to extend our web application app. We're going to define our route group. So let's define var group equals app.mapGroup. The root path for this group is going to be just genres. And we're only going to have one endpoint here, but I think it's good to follow this convention of having a group and then just attaching all of the endpoints into that group. And really the endpoint we want to define here is going to be a get endpoint that is going to respond to a call to genres. So for that, we're going to do group.appget. We're going to go into the route just under genres. Then we're going to define our async handler here. So it's going to be async. It is going to receive our game store context, db context. Let's make sure we do control dot so we can use gamestore.api.data. And then this is going to point to the following implementation. Perhaps let's close this for now. Here we want to do await db context dot genres. And we're going to project this, right? So we're going to do select genre new genre DTO, which we have to do control dot to use gamestore.api.dtos. And for the genre DTO, we're going to return the genre ID and the genre name. We will ask EFCore to not track these entities because we're not going to modify them in any way. So as no tracking. And finally, we turn this into a toList async, which is going to complete our asynchronous invocation. So yeah, that's pretty much it. That is our definition of our one endpoint there. And of course, now we also have to go back into our, let's go File Explorer, program.cs, and perhaps just down here, after our map games endpoints call, we can do a call to app.map genres endpoints. And well, that's pretty much it. Our new endpoint is ready and we can try it out right away. Let's do Ctrl J here to start our terminal. Let's go into gamestore.api and let's do .NET run. Okay, it is running. Ctrl-Shift-E. Let's go into games.http. Have to close this. And what I'll do, let's just go all the way to the end to introduce just one more request here. So triple pound, we will do get. The host and port are going to be the same. So I'm going to copy host and port from the delete call right there. And here we will just put generous. Now let's click on send request. And on the right side, we can see that we got the expected 200 OK. It was a success. And down here, we can see the full list of all of those game genres that we have stored in our database. So our backend API is complete and it is ready for integration with the frontend application. Even when this course is about ASP.NET Core, I find it really useful to see how the API that we built across the course can power a real and modern user experience. For that, I have prepared a small React application that is ready to talk to our .NET API. Now, in this course, I won't go into the inner workings of this application, but I'm going to show you how to configure it to start talking to the API that we created. So as you can see, I have a new directory here, gamestore.react. This is the React application. And if we open this, we're going to find a bunch of files, but the main file that we want to look at quickly here is byte.config.ts. This is the file where we define the configuration for the local execution of the application, in this case, using the bit.dat server. The way that things have been set up, anytime any of the components of this application need to talk to the backend, they will invoke the /API location, which via this proxy configuration is going to point into our backend URL. Now, where is our backend URL? Well, let's remember that quickly. If we go into Ctrl-Shift-E, our Explorer, let's go into our GameStore API, properties, launch series.json. And remember that here we have our HTTP profile where we define our application URL for local development. So all I'm going to do is copy this application URL, copy, Ctrl-Shift-E. Let's go back into byte.config.ts and let's paste that location over here. And with that, we are ready to see the full stack application in action. So I'm going to do Ctrl-J to open my terminal. Perhaps I'll maximize this. In this terminal, I'm going to start our server application first. So our gamestore.api, I'll do .NET run. And then I'm going to use this plus button here to open another terminal, which is the one that I'm going to use to start the React application. So I'll go into gamestore.react. And since this one is based on Node.js, I'll have to do npm run dev. And the application has started. We can see the local URL of the running React application over here, which I'm going to copy, localhost 5173. And here in my browser, I'm going to paste the location there, hit enter. And here we are in our application. As you can see, the home page right away went ahead and loaded the two games that we had created before via the REST client in VS Code. Now, to confirm that this application is actually talking to our backend, one thing that we can do is just press F12 here to load the browser developer tools. And if we go into the network tab over here, here's the network tab, we're going to get this section over here where we're going to see all of the calls that the frontend is making into the backend. So I'm going to just refresh this. I'm going to see there's a bunch of calls right here on the right side, which represents all of the actions and the things that the frontend did as it was trying to load. Now there's a lot going on here. So what I'm going to do is just filter via this button here. I'm going to filter only the calls that go outside and into our backend. So for that, I'm just going to click here in fetch/xhr. So that's going to reveal only the fetch calls, where fetch is the API in JavaScript that you can use to talk to an external service. So here we can see that we have a couple of fetch calls. Let's click on one of those. If we expand this, we can see that right here is our request URL that is going into the /API/games location. Now, how does that get into our actual backend API because the API is not really living in 5173. However, the way these things works, like I said, is that back in VS Code, if we look at our byteconfig.ts, let me collapse this, the frontend calls into /API, and then /API is translated into our actual location where the /API part is removed, and then we are just going to call the rest of the path. And the rest of that path is going to be just /games, which is what represents the endpoint in our .NET API. Next, we can go into our UI and just click on new game to start creating our new game. And you can see also here, let me collapse this for a moment, that now our generous endpoint has been invoked right here. You see, there's a call to generous. If we click on that, we're going to see the actual route to get into our generous API, the one that we just created. It's right there. Let's create a new game. Let's say that this is going to be our Astrobot game. This is going to be a platformer game. Here is the price. And for the day, we're going to do 9/6/2024. I'll close this, then I'll click save. And you're going to see right here, we have our call to games with a 201. This is the call to create the game. We can click on it. We can see that this was a post request, and we actually got the 201 created in a similar way as we got in the REST client in VS Code. We can also try updating the game. For instance, here's Street Fighter 2. This is going to be now Street Fighter 2, let's say Super. The price is going to be, let's say, just $7.99, very cheap. Click save. And the game has been updated, as we can see right here. Finally, we can go ahead and test the deletion of one game. So let's say that we don't want the Super Mario Bros. Wonder game anymore. We can click on the delete button here, click on delete, and the game is gone. So there you go, a modern full stack application powered by your .NET API and a React frontend. So where do we go from here? First, code organization. Right now, everything is in one place, which becomes a nightmare in big applications. You can use vertical slice architecture to keep your features clean and isolated. Then, authentication and authorization, and specifically how to secure your APIs with Microsoft Entra ID, the industry standard across most enterprise organizations today. Next, you should learn how to test your API endpoints the way real requests hit them, also known as integration testing. Then, you will want to take everything you built, containerize it, and ship it to the Azure cloud. This is where your code becomes a real product. And when you're ready, go full stack with a modern React frontend to experience a real-world application end-to-end. Master these skills and build production-ready backends step by step in my .NET Backend Developer Bootcamp. You can check out all the details at netacademy.io/bootcamp. Thanks for watching, and I'll see you in the next one.